Hello, hello. Hi, everybody. How's everyone doing today? Some people are doing okay. Other people are face down their computer. That's okay. We're still going to have a good time. How's everyone doing today? Good. That's a little better. All right. Awesome. My name is Andy Knight, and I'm the Automation Panda, and I will be your instructor for today. Just curious, are y'all fairly familiar with Python? Say you have at least intermediate level experience? Okay. What kinds of roles do y'all do? Raise your hand if you would consider yourself a developer or a software engineer. Okay, oh wow, a lot. Anybody who primarily would consider themselves a tester? Oh, a couple. Anyone who maybe like data science, more DevOps oriented? Okay. Managers out there? Oh, we got okay. Very cool. Any other roles I didn't mention? Awesome. Woo! I wish I had a prize for you. Cool. Good to know. That kind of helps me gauge what's going on here. Also, some more questions. Has anyone ever done automated testing, whether that's unit testing, web UI testing? Raise your hand. Okay, so man, it seems like almost everybody has touched it. Has anyone used Playwright before? That's what we're here to learn, right? One guy over there knows, so you're going to be my little helper, right? Sweet. All right. Cool. Fantastic. So, like I said before, I am the Automation Panda. I like to talk and write about testing things. Be sure to read my blog at automationpanda.com, as well as keep up with me on Twitter. You can reach out to me anytime after this workshop. Be like, hey, Andy, what's going on? Got a question? Twitter's probably the best way to reach me. Plus, give me them nice, awesome follower counts going on. Sweet. Right. So right now, I work as a developer advocate at this awesome company called Applitools. Anyone know what Applitools does? Yeah, specifically visual testing. Anyone do visual testing before? Let me show you what visual testing is all about. So, we got this picture here. Can we spot the differences? Got this happy little underwater scene. Take a moment and see how many differences you can spot between these two pictures. How many did we find? So 5, 6, 8, 7. Okay, let's name them out. What we find? Mouth is different. That's one of them. Bubbles, crab. There's a whole missing fish, right? Yeah, the star. Yep, okay. So we can look at this manually ourselves as humans and try to spot all the differences. What Applitools Visual AI does is it does this very, very easily. There are actually 10 differences between these. Nobody got 10, did they? No, we got like 5, 6, 8. This is the power of automated visual testing. Imagine doing this kind of thing on your web apps or your mobile apps. You know, you make a change. How do you know that it's good? Well, maybe it accidentally made your layout shift over or a button disappear. You can incorporate automated visual testing techniques like this into your test cases and help catch errors and visual bugs like these. I like to say if a picture is worth 1,000 words, a snapshot like this comparison is worth 1,000 assertions. Other things I do at Applitools, other than help people spot the differences, is I run this thing, or I'm director of this thing called Test Automation University. Has anyone heard of this before? Raise your hand. Nobody's heard of TAU? Oh my gosh. That's okay. So TAU is an online platform for learning about testing and automation. We have courses from some of the most awesome instructors across the world. Currently we have about 70 courses or so. So if you like this workshop and you want to learn more about testing and automation stuff, I would highly recommend checking out TAU. It's a pretty awesome thing. Okie dokie. So with all of that front matter out of the way, let's talk about what we're going to do today. The name of this workshop is Awesome Web Testing with Playwright and Python, or something similar to that, right? If that's not the webinar, or if that's not the workshop you came for, sorry, you're in the wrong room. But my goal today is not so much simply to teach you how to use Playwright as a tool. What I want us to learn today is how do we build good test automation projects for web apps, right? And this tutorial is one that I've actually given quite a few times in different forms. If you notice, this is me. I'm still wearing the same shirt. I even got better jeans this time. Check this out. But this was taken at DjangoCon 2019. And at DjangoCon 2019, I gave this workshop, except I used Selenium instead of Playwright. And I did the Selenium workshop a number of times. In fact, at PyCon 2020 Virtual, I gave this workshop, and it was Selenium. So you might be wondering, Andy, why did you flip over to Playwright? Simple reason is, I think Playwright today is a superior browser automation tool to Selenium. Now, each is good. It doesn't mean Selenium sucks or anything. Selenium is still very good. But I believe Playwright is more Pythonic. I believe it is more feature-rich. And I believe it helps you write better tests more easily. So now, instead of building the test automation project in Selenium, we're building it with Playwright. If you really want to do Selenium, all the stuff I'm going to show you today, almost all the stuff I'm going to show you today, you can do in Selenium as well as Playwright. I just think Playwright's easier, better, and safer. So, what is Playwright? Playwright is a browser automation tool at its core. I would not call Playwright a full framework. I would call pytest a framework. But what Playwright helps you do is it helps you automate end-to-end tests through a web UI very easily and very simply. In that sense, it is very much like an alternative to Selenium WebDriver. Playwright is an open source project. It comes from Microsoft, the same group in Microsoft that has brought you things like Visual Studio Code and TypeScript. They're all under the same organization. Currently, they have about, I think, 6 engineers or so on it. And Playwright is also available in multiple languages. Today, obviously, we're going to learn Python, right? It would be pretty weird if we didn't do Python at PyCon. But you can also use Playwright in JavaScript, in Java, and in C#. So in that case, it's very much like Selenium in that it has multiple language bindings. The other major browser automation tool out there is something called Cypress. Has anyone heard of Cypress, perhaps? Yeah, if you've done front-end JavaScript web dev, you may have heard of Cypress, may have even used Cypress. Playwright and Cypress are kind of similar in that they're more modern browser automation tools that are feature-rich. Some of the things that makes Playwright distinctive, other than the multiple language bindings, it uses debug protocols within your browser instead of the WebDriver protocol. What does that mean? You can use either protocol. Selenium WebDriver uses the WebDriver protocol, but debug protocols typically are faster, a lot faster. So that gives Playwright a significant speed boost over a Selenium WebDriver implementation. Some other advantages Playwright has: automatic waiting, which we'll look at, easier browser setup. If anyone's ever done a Selenium WebDriver setup, oh my gosh, the versions and the paths and stuff, oof, that can be a thing. It's doable, but anywho. Does anybody have any initial questions about what Playwright is before we start learning it? Okay, very cool. So, I mentioned this to folks as they were trickling in, but all of the stuff we're going to do today is in this GitHub repository. Now, this is not something that we're going to clone and work within, but rather you can use this as a reference as you go. The hands-on coding we're going to do will not use this repository. We will literally be at the keyboard in Visual Studio Code programming the automation as we are going through the tutorial. What this is here is, first of all, it is the completed example code for the project. In fact, at each step of the project, I have different branches for each chapter. So if you're stuck in the second part that we're going through, you can always reference this in a browser and be like, oh, what's the code supposed to look like? Also, you might want to have this open so you can copy and paste easier than just typing everything out slowly. But more importantly, in the tutorial folder of this repository, you will find all the completed instructions for this entire workshop. It comes in 6 parts. We will probably tap out around part number 5. Anything that we do not get done, you can complete as a take-home assignment. What I want to do today is not so much have a race to the finish, but I want us to make sure that we get through as much as we can, but still have time to discuss when we have questions or solve problems as they come up. This is meant to be interactive. So if you hit trouble along the way, raise your hand. If you have a question because you don't understand something, please bring it up. Don't suffer in silence. Does that make sense to everybody? All right. So, are we ready to begin? Okay, very cool. So let me get my terminal open here. Oh gosh, where did it go? Wrong screen, my bad. Is that, oh, we can do better, we can do better. Okay. So first thing we're going to do is, excuse me. Oh wait, no, I don't want that first. Actually, first thing we're going to do is we're going to talk about the test case that we're going to automate. Duckduckgo.com. Okie dokie. So this may sound basic, but we are going to spend 5 chapters of this tutorial automating one test case. You're like, what? Don't we want to do multiple test cases? Trust me, this is going to be a thorough walkthrough, and you're going to come out better for it. But we need a test case to do. I'm a strong believer that we want to write our test cases before we write our test code. Right? Test code is simply an implementation of a well-formulated test case. And the test case that we're going to automate together today is a basic search using DuckDuckGo. DuckDuckGo is like Google or Bing or Yahoo, just different. Why did I pick it? Because the locators are more consistent, not because I have any sort of preference one way or the other. So how do I go about doing a DuckDuckGo search? What's step 1? Go to the site, load the page, woo! Go to duckduckgo.com, wait for the page to load. Awesome. What do I do now? Do what? Yeah, what do we want to search for? We want to search for pandas. Why? Because pandas are awesome. We could do Pikachu as well, but that's all right. So I type in panda. Now what? Either enter or... Ah, okay. We'll click the search button. Now what? Read. Oh, right. We did our interactions. Now we have to do our verifications. Here's the result page. How do I know that this result page is good? Sorry, what? There's pandas on it. Where do I see pandas on it? You see some panda images. Where else do we see pandas? We see words. Where do we see the words? There we go. So we have the hyperlinks have those titles that have, you know, like Panda Express. I don't know what this is. This looks like some sort of ad. But if we were to scroll down, yep, here we go. Giant panda from National Geographic. We've got panda facts, right? Okay, so we can look at links. Are there any other interesting places on this page where pandas might appear? Maybe the search bar up here has the same search query, or maybe the page title in my tab, right? So these are all different points that we could check. We could check the title, we could check the search bar, and then we could scrape the different hyperlinks to see if they contain the title panda. If you wanted to match images, you're going to have to get Applitools for that, and we're not going to do that today. But it's good, right? So when we go to formulate test cases, testing in a nutshell is interaction plus verification. Doesn't matter what kind of testing you're doing, functional testing, unit testing, integration testing, performance testing. You do something and you make sure it works. Interaction plus verification. So we had our interactions, load the page, type it in, boom, wait, and the verifications of scrape things off the page and make sure that they're doing something good. Use some sort of assertions there. Has anyone heard of a pattern called arrange, act, assert? Raise your hand. Only one person. Oh my gosh, this is breaking my heart. That's okay. That's what we're here for. We're here to learn. When I was at the testing conference, everyone knew arrange, act, assert, and nobody knew Python. If you take away something big from today, take this away. Arrange, act, assert. Write it down, write it on your arm, type a note, tattoo it to your back, whatever. This is how you write good functional test cases. This is the pattern for identifying individual, independent behaviors for good testing. You set the things up, you interact with the things, and you make sure they work. Arrange, act, assert. This pattern is something that I believe originally came from the .NET community 10, 20 years ago, and it was used primarily as a pattern for unit testing. But it applies as well more broadly for any kind of functional testing because it helps you frame the things you want to test well, right? For example, like if I wanted to, we just did the Panda search, right? If I wanted to then like test to see what happens when I do an images search, that would arguably be a separate, or should be a separate test case because it's a different behavior because you would have arrange, act, assert, and then act, assert. You want to separate those out. You don't want to repeat your act, assert steps. Separate behaviors, better testing, test case independence. Does that all make sense? Cool. Arrange, act, assert. Wonderful. So, now that we know what our test case steps are, let's then take that test case and put it into test code. We have a problem, though, because we don't yet have a test code project to do that, do we? No. Guess what we're going to do now? We're going to create the project. So I am going to drop to the terminal to create directories and stuff. You can do this from within Finder or Windows Explorer or whatever way you want to do this. But basically, I am in a directory where I want to create my project. And I'm going to call this something, McDear, Playwright Python tutorial or something. Right. Okay, and inside this directory, we'll change directory inside of there. I want to create another folder, McDear, called tests. Okay. So now I'm here and basic structure. We'll explain why this in a moment. I also need some dependency packages, right? Because Python standard library is not going to have all the stuff I need. So I need to install some testing things, including Playwright. Is everyone familiar with virtual environments? Anybody not done that before? It's okay. We're in the safe space. Okay, so we all know then that you can install Python packages globally for your whole machine, and everybody shares the same thing. Or you can define them using virtual environments per project to kind of keep those protected and safe. And typically, with good programming practices, we want to do that local virtual thing. And there's many ways to do that. You can use Poetry or virtual env. I like using the VNV module that's in the standard library. So that's what I'm going to do. I'm going to create a Python 3 VNV, and I'm just going to call it VNV because I'm boring. Boring is good. Simple is better than complex. Okay. Is that in Python, everybody? Okay, cool. And I'm going to activate my virtual environment. Boom. Okay. If you're on Windows, the command will look something like VNV. What is it? Scripts. Yep. activate.bat. That would be where the path is on a Windows machine. But I'm on Mac. I have one of these new M1 Macs. Oh my goodness, they are amazing. Highly recommended. So cool. No, Apple does not pay me money. I work for Apple Tools, not Apple. Okay. So when you've activated your virtual environment, you see the little parenthesis thing. That's how you know you're in there. Okay, so there are 3 main packages that we need. First package we need is Playwright. Pip install Playwright. Thankfully, it's the name of the name of the tool is the name of the package, which is pretty cool. That should go fairly quick. Playwright is going to handle, like I said, our browser automation. It is not a full framework. It is a browser automation tool. It's the thing that helps us go to Chromium and say, click the button, or give me the text. Another thing we're going to install is pip install pytest. Has anyone used pytest before? Yeah, oh my gosh, I love pytest. Who here loves pytest? Yes. I do test automation in very many languages, on very many kinds of projects, testing tons of different kinds of things. And pytest is my favorite test framework in any language. Close second is SpecFlow, which is C#. But pytest is just so awesome for so many reasons. And if you want to gush about pytest with me, we can meet up after this and we can have a fan session. I've given talks on this. Other people have given talks on this. I strongly prefer pytest over Python's baked-in unit test library because pytest is more extensible. Pytest uses functions instead of classes. I have a whole opinion about that. And so Playwright, today we're going to use Playwright with pytest. And that is what, honestly, I would recommend as the recommended practice. Because of what I'm going to show you next. Playwright and pytest work awesome together. So let's install pytest. And it might suck in other packages too. That's totally cool. And finally, third package. This is where magic happens. We're going to pip3 install pytest-playwright. Oops. Now it's like, wait a minute. I didn't install Playwright, then I installed pytest. Now I need pytest-playwright? Yes. This is the pytest plugin for Playwright. So pytest is extensible. You can write your own plugins that add fixtures and all this other stuff. The pytest Playwright plugin is amazing. Playwright by itself is pretty awesome, but it needs a little bit of boilerplate code. This plugin, which also comes from the Microsoft Playwright team, simplifies all of that. And so it streamlines our automation development. So if we look then, I could do a pip freeze, and we can see all of the dependencies that we should now have in our virtual environment. We can see we have Playwright. We can see we have pytest. We can see we have the plugin. There's a lot of P's and PL sounds. And we have all the other Gorp that got sucked in. Yeah. Cool. So everybody with me so far? Everybody got the packages installed? Anybody having trouble so far? Awesome. Good. Yes. Yesterday, it took like half an hour just to get everybody to this point. This is good. We're doing good, y'all. Yes, this is amazing. Whew. Go Python, go. Love the Python community. Love the testing community too, but they need to do more Python. Yeah, okay, so I occupy this weird intersectionality between testing world and Python world. There aren't very many of us. But Python is used by a decent slice of the pie in the testing world, but most of the test automation still to this day is Java and JavaScript. Little slice of Python, little slice of .NET, and a really little slice, ever decreasing, of Ruby. Other languages just basically do not exist in the test automation space at large. I've got data to back it up. If you want to find that out, I can share later. Okay, so final thing we need to do is we need to install the browsers for Playwright. Now you might be thinking, hey Andy, wait a minute, time out. I already have Chrome on my machine, or I already have Safari, or I already have Firefox. What do you mean I need to install browsers? Is this like that WebDriver executable thing? No. So one of the unique things about Playwright is that Playwright doesn't actually directly test the main browsers you have installed on your machine, right? It doesn't directly test Google Chrome. It doesn't directly test Microsoft Edge or Apple Safari. Instead, it uses browser projects, or what you might think of as browser engines. It uses Chromium. It uses the Firefox open source piece, like the Gecko, whatever it's called, but they call it Firefox here, and WebKit. You're like, what? Wait. I want to test Chrome and I want to test Safari. Why am I testing Chromium and why am I testing WebKit? That seems a little weird. Well, the reason why Playwright does that, and it is opinionated, is that you can get pretty much the coverage you need off of just those browser projects. You don't need the full stock browser with all the other bells and whistles and features. Like Chrome, you know, you've got your bookmarks and you've got your caching, you've got all these settings and all stuff. When it comes to web UI testing, really, you just need that rendering engine to make it go on the boom, you know, on the screen. So the Playwright team took a design decision to say, we're not going to mess around with stock browsers on the machine that you're testing on. We're going to simplify, use browser projects, and that will make things easier to set up and more efficient. That's the opinion. Now, if you're in a company or team or org where you have very strict requirements around the browsers that you do test for compatibility reasons or whatever, like if you're working at some government org and they say you absolutely must test the last 5 versions of Google Chrome, and it has to be that, and you can't not do that, Playwright ain't going to work for you. Sorry. But 99.9% of shops doing this kind of testing is going to be totally fine. So that was, you know, part of the thought there too. So to install the Playwright browsers, what we do is we run a command Playwright install. Now mine is going to no op very quickly because I already have the 3 browsers installed. But when you do this, you should probably see immediately it's going to start downloading Chromium, and it's going to slowly start ticking away. Am I right? Yeah, you've seen it. Okay, cool. It's going to download Chromium, then it's going to download Firefox, then it's going to download WebKit. Probably in that order because that's the alphabetization. This step might take a little while, especially on conference Wi-Fi. That's not a problem. You could let this go in your terminal while we move on to other things. But just make sure that everything gets fully downloaded and installed. You don't need to install anything else after this. Playwright install, it gets the browsers, finishes. If it's successful, you're good. You don't need to add anything to your path explicitly. You don't need to download another executable file. This gets the job done. Yep. So, was that a question? Okay. Cool. So, fire that off. Let that go. If it freezes, try killing it and restarting. I would guess it'll probably take about up to 5 minutes for it to fully install. In the meantime, let's go back into that project directory that we created. So I am going to open Visual Studio Code, and I am going to make my color theme a little easier to see. I'm also going to increase the size here, so hold on, hang tight. Open. So, code, scratch, Playwright Python tutorial. Control plus. Is this text a good size for everyone to see? Okay. Hold on. Okay. So, I like using Visual Studio Code with the Python extension. It's pretty awesome. I also like using PyCharm. PyCharm is also awesome. I just recommend that you use a good Python editor, especially when it comes to the autocomplete stuff for, you know, figuring things out as we go. So here we are in our project, and it is right now empty. We have the name of the directory. Top level, we have our tests directory, which is empty. And we have our virtual environment directory, which if I were committing this to source control, I would add VNV as a path to my gitignore file. So that wouldn't be committed. Whenever you are automating tests with pytest, whether it's unit testing, integration testing, and end testing, the conventional practice is all test modules go under the tests folder. You can change that if you want, but simple is better than complex, and readability counts, and I would recommend going with convention. So we're going to go with convention today. In here, we're going to put our test module. I'm going to create a new file under tests, and I'm going to call it test_search.py. Again, convention in PyTest is that your modules that contain test cases not only appear in this directory, but then start test underscore. PyTest does this magical little discovery thing, and everybody's happy. So in here, we're going to put our first test case, and that's going to be that basic Duckduckgo search test that we did before. Def test basic Duckduckgo search, parentheses, boom. And we're going to make that, we're just going to leave that blank for right now. We're going to put a pass in there. What I like to do when I write my test cases, as I said before, I like to write my test cases before I write test code. And so I actually like to write my test steps in comments inside my test case. And then when I go to implement it, I will, under each of those steps, put the implementation code. So, and also, I like to phrase my steps in that arrange, act, assert pattern. Furthermore, I like to use given, when, then language. Arrange, act, assert is the equivalent of given, when, then. Has anyone used given, when, then before? Yes. So y'all know, so gherkin, yes. Oh, I love gherkin. Oh, I love gherkin. That's a whole nother topic. We're not going to get in there today, but oh, I love gherkin. Gherkin gives you the guardrails of writing well-defined behaviors. That's why we write our tests, arrange, act, assert, given, when, then. So, given the DuckDuckGo homepage is displayed, when the user searches for a phrase, then the search result query is the, is the phrase, and the search result links pertain to the phrase, and the search result title contains the phrase. All right, so basic plain language descriptions. We have not only described our test, but we have dissected it into the phases, the arrange, act, assert, and then defined them carefully with given, when, then format. And so these will kind of guide us along as we go to automate, right? Even as we write the Python code, I will still leave these lines in because that shows a very descriptive line of what's going on, followed by the implementation, right? Kind of separated by paragraphs, if you will. And that preserves my test case within the test code. One thing I want you to remember, another nugget of wisdom to take away today, is test engineering is not just about automating some scripts. It is about developing good test cases. A test case is more than the automation script. A test case is this. The script is just how it runs. Got a question in the back?
Particular reason why this isn't the doc string for this function?
No. You could put in a doc string like this. Oopsie. Oh gosh, hold on. And then pop all your given, when, then stuff here. You could do that. The reason why I'm going to be putting it in comment lines like this is because when we write the code, I'm going to be doing like Python stuff here and Python stuff here, and so it kind of follows along with it. That's all. Personal preference, coding style, readability counts. So everyone knows the XenPython, right? When I say XenPython, does anyone not know? Here, I'm just, in case there's anybody who's shy, open up your Python interpreter and do import this. These are the set of guiding principles for the Python language. Beautiful is better than ugly. Simple better than complex. Readability counts. That's where I'm pulling all these things. So Python community factoid right there. Just want to make sure everybody knows this. It's fun stuff. Okay. Alrighty. So now we have our test case well defined. We have project set up. Has everyone's Playwright been installed by this point? Okay, good, good. There was a snafu the other day, and it didn't download for some people, and I was like, oh my gosh. So what we can do now, just to make sure everything is kosher, let's run this test, just to make sure Python, or not Python, that pytest is there, it can discover your test and all that. So to run your pytest test, be at the top level directory in your project, so Playwright Python tutorial, Python 3-m for running a module, pytest is the module we want to run, give it the path to the tests directory, and now pytest will discover everything in our test directory, find the test functions, and run them as test functions. And it should know what pass. So you should see something like this. Here's the one module. The green dot means passing test. Summary, one test passed. There's nothing going on here. It was a no op. But we just want to make sure that the framework identifies and runs. So everybody good? Anybody have an issue running the test? Good. Oh, thank goodness. Wonderful, wonderful. Cool. Other thing I will mention here, we created a whole new project for our test cases. You may or may not want to put your tests in a separate project from the application you are testing, right? It's an age-old question, should you put your tests in the same repo or a different repo? There's pros and cons to both. It's usually a best practice to put your tests in the same repo so that they can be version controlled together, so that developers can get to them more easily. Times you would not want to do that would be if your test cases are actually covering features that span separate repos, then you might want to put it separately. Or if your dev and test teams are like completely separated by brick walls and never talk, which there are other issues with that, but if it's like a burden to constantly have to clone the dev repo and it's like gigabytes large and you have a very small test repo, then it might make sense to separate. I just want to kind of throw that out there. We're creating our own directory because we're starting from scratch. Does that make sense? Cool, cool. All right. So all that boilerplate out of the way, who's ready to actually do some Playwright stuff? Yeah, sweet, sweet. Let's do it. Let's do it. Okay. So first thing we need to do is we need to set up Playwright for the project. No. Sorry, we already set up Playwright for the project. We need to understand how to manipulate browsers with Playwright. That's what I'm trying to say. So we already have gone over that Playwright uses browser projects, not full browser, like stock browsers on your machine. So we're going to be testing against Chromium or Firefox or WebKit. But there's another efficiency that comes into play with how Playwright treats browsers. Raise your hand if you've done stuff with Selenium WebDriver before. Okay, so there's a good number of people. So with Selenium WebDriver, when you set it up, how it goes is, in your code, you will, for every test case and a setup routine or at the beginning, you're going to initiate a WebDriver instance, right? You're going to say like driver equals new Chrome driver. And what that does is it goes to your path, finds the Chrome driver process, starts it as a new process on your machine, which then in turn goes to the Chrome browser instance on your machine and starts that as a process. And then the WebDriver interacts with that. You say things like driver find element, driver navigate, all those kinds of things. Then you do all your stuff in your test, and at the end of the test case, you will do driver.quit. And so you'll quit the thing, and that kills the processes, and so it cleans it up. Then the next test case in your suite comes along and repeats the whole thing. And it is a strongly recommended practice that every test case has its own WebDriver instance that you start and stop, because we all know WebDriver is a little flaky. We all know that the longer a WebDriver instance lives, the more likely it is to do something terrible. And also, if you're parallelizing your test suite, every test needs a separate process anyway. The problem with that is every time you're starting up not only a WebDriver executable process, but also a full browser process, that is slow and resource intensive on your machine, We all know how many bajigabytes Chrome likes to suck out of memory. And so the process of starting and stopping browsers for every single automated test in your suite could be anywhere from like 2 to 5 seconds, maybe even 10 seconds per test, right? And you think, that's not too bad. Imagine you have a suite of 100 tests. Imagine you have a suite of 1,000 tests, right? That is a huge time tax, but it's necessary to preserve test case independence. So what Playwright says is, well, wait a minute, time out. We can get away with only one browser instance, one instance of Chromium, one instance of WebKit, or one instance of Firefox, and using that one instance, what I can do I can create one instance on a per test suite basis, but on a per test case basis, I can peel out browser contexts. Now, what a browser context is basically like an incognito session within your browser. So it has all of its own cached state and stuff in and of itself within, that browser address space and process. But contexts are essentially isolated, almost as if these are 2 Docker containers. And contexts are super fast to spin up. We're not talking seconds, we're talking milliseconds. So typically what the execution flow of Playwright test suite would look like is you would start before any test run, let's say a Chromium browser instance. Then at the start of each test, you would spin off a browser context. And at the end of the test, you will close the browser context. So that way, you're getting massive performance savings, right? When it comes to test automation efficiency, it's usually not about like the interaction, like the actual execution of the browser interactions. It's the waiting for those and the setup and cleanup of all the browser stuff. That's where you really get slow. So, furthermore, within a browser context, you can also have multiple pages. Typically, you'll only ever need one page per test case because you're going to load that page and navigate through it and click and scrape. But you could, in theory, have multiple pages per context. That would be like you click a button and it opens in a new tab. That would still be within one context, but it would be a separate page. So, all that to say, when you go run your Playwright test, there is a browser context, and a page. Browser is for the whole test suite, context is for test case, and pages, usually you'll only need one per test case. Does this make sense? Okay, good. So, conceptual stuff. How do we actually make that happen? Let's get back into the code here. So, if you were just doing Playwright on its own, like no pytest or anything, you'd have to do something like this. You'd have to say something like, okay, first of all, I need to get a browser goals, I don't know, like Playwright. Don't write this down, by the way. I just want to show you the example. We're going to delete this in just a moment. Chromium. You need to launch a browser. Then you need to get a context from that browser. And then from the context, you need to get a page. And so essentially, like, this is basically what we just talked about in terms of the concepts, right? You kind of need to do this in like once per test suite, but then you need to repeat this code all the time. That's not good. We don't like to repeat code. Repeating code is bad. So remember that pytest Playwright plugin we installed? Remember, like, what is that? That will take care of all this for us automatically. So we can just say, hey, give me a page. So instead of doing this, what we can do is this. From Playwright, import, Playwright.sync API, import page. This is a type, because we're going to use type annotations. Has everyone used type annotations in Python? This is becoming pretty ubiquitous. It's optional. I highly recommend it. We're going to do it today. So if it's new to you, just kind of follow along. It'll be cool. Pick up another new skill. And then here, all I'm going to need to do is this. And I'll add the type annotation here for this. So in pytest, this is a fixture. A fixture is a special function that you can use to do setup and cleanup. A fixture runs before your test. It'll create whatever objects, return that object, and then when you declare it in the arguments of a test case function, whatever's returned gets injected into this function. So page is the name of a fixture from that pytest Playwright plugin for constructing a new page object off of a browser context, off of a browser. So we didn't need to do any of that. All we need to do is say, hey, give me a page. Give me the page. And it gives it to you. Easy, right? Isn't this amazing? Yes, no? Yeah, there we go. Okay, cool, cool. It is amazing. I thought it's amazing. Okay. So this will give us our page very simply. Once we have our page, now we can start doing stuff with the page. So let's implement this first step. Given the DuckDuckGo homepage is displayed. A lot of Playwright calls are going to start with your page. Why? Because stuff is what's happening on the page. Page dot. Now here, the type annotation plus the fact that I'm using an editor like VS Code is going to give me this wonderful autocomplete. So I will be straight with you. I don't know the whole Playwright API. I don't need to, but because I can just go kind of figure things out. If I'm not sure, like, hey, how do I load a page? Like, do I navigate? No. Do I go to? Oh, I go to the page, like this. So if you want to load a page, page.goto, and then you can see here it also gives you the context help. What do I put in? You put in the URL as a string. So https, yes, / www.duckduckgo.com. Oh, yes, boom. And that's how we do it. Make sense? Questions, concerns? Seems pretty basic, right? One other thing I want to shout out. You may have noticed this part of the import, playwright.sync API. You can use Playwright in Python either synchronously or asynchronously. You can choose which one you want to do. For almost all testing purposes, the sync API is sufficient. You don't need to make it async. All you're going to do if you do that is, oh, what was that? Uh-oh. How's that? Sorry, folks. All you're going to do if you do async is just start adding await calls to like everything. And it's not really going to make a huge difference for this application. So I'm going to stick to using the sync API. If you look at the docs online for Playwright Python, almost all their stuff is the sync API, though they show you how to do the async one. It would make sense to do async if you're using Playwright for something other than automating tests. Like if you just wanted to make a web scraper or something. That would be when you'd want to use async. Does that make sense? Okay, cool. So, who wants to run this test? Yeah, let's do it. So let's come back down to our terminal, and let's run the test and see what happens. 3, 2, 1, go. It passed. Yay, did it all pass on your machines? But there's just a problem here. I didn't see anything. I didn't see it. Did any of you see anything? No. Oh man. When I'm developing tests, I want to see it happen because seeing is believing, right? By default, when you run your tests, Playwright uses headless mode. So you can't see anything. That's a good thing because when you run your tests in, let's say, a continuous integration environment, you want it to be headless because you don't want it to use those extra resources or anything. You want it to be fast, lean, all that good stuff. But when we're developing tests, we want to use headed mode because we want to see the things to make sure it's actually doing what we expect. So to run it in headed mode, you can add a command line option, -- headed, like this. This is another nifty thing about that the pytest plugin it will add these special things to the pytest command line. Another reason why we use that. So let's run it in headless or headed mode and see what happens. See the browser, it's coming up, and it should be navigating. Man, that's really slow. What happened? There it goes, boom. Let me try that one more time. That seems like really slow. There it goes. Okay, boom, boom. So we saw it came up really fast and then closed. Because all we did was load it, and then the test is done. Did headed mode work for all y'all? Yeah, sweet. Now, another frustrating thing, though, with that is Playwright is very fast. Usually, like, it'll be like bloop, bloop, like really fast, like boom, boom. And you won't be able to track it kind of like at human speed because it's moving at machine speed. Not only do I like to do headed mode, but I like to slow it down while I'm developing. So there's another command line option called --slow-mo, S-L-O-W-M-O. And this, you can give a number of milliseconds to slow down every single interaction the Playwright performs. So I like putting in something like 1,000 or 2,000, 1 to 2 seconds. Let's see what happens when we do this. So that gives us a little bit of pause to see, like, oh, it actually did load the Duckduckgo page. Cool. All right, everybody with me so far? Cool. Who's ready to do the next step? Sweet. So, given Duckduckgo homepage is displayed, when the user searches for a phrase, how do we search for a phrase again? We got to enter in that the search bar. So if I go back to my browser, how do we know where this search bar is located on the page? How do we tell Playwright where that is? We have to use something called a locator. Have y'all used locators before? Maybe some, maybe not. Okay. Locators are a pain in the butt. Real talk. Locators make web UI automation a pain. That plus waiting, but waiting is problem solved. We'll see that in just a moment here. So, when we look at a page as humans, we see this visual thing, right? When you look at the page as a browser, I'm going to inspect the page code. It's a bunch of HTML. There's also some CSS thrown in there for styling and maybe some JavaScript to make it move. But the structure of the page is defined in HTML, and it's all these different tags and stuff. And so every element on the page has a corresponding HTML tag that defines where and how it should be rendered. So in this case, what I want to do is I want to find the HTML tag for this particular search bar. Google Chrome makes this really easy. Like I showed, you can right-click and go to Inspect. It opens up Google Chrome's Dev Tools. And in here, there is a pane called Elements. I know this is really small. I'm so sorry. I don't know if, am I able to zoom this in? I don't know if I can zoom in on this. Oh, we can, cool. It's marginally better. But just right-click, inspect, you'll see it on your machine. And so you can see the entire HTML source of the page. Then what you can do, in this upper left corner of Google Chrome DevTools, there's this like little arrow with a box. Click that, it should turn blue. Then when you hover over the rendered web page, you'll see like it's highlighting a section for that element and then showing you the corresponding HTML code in the source. So what I do is like, okay, I want to get this search bar. I highlight the search bar and I click it. And then here, I come over here and look, okay, so that search bar is this input element. From this input element, then my next thing is I need to come up with a selector that will pinpoint that element. Because what a locator does is it points to that element on the page. Locators are just pointers. The selector is the query that we're using to build that locator. And so you can have selectors of many different types. The easiest kind of selector would be if you have a unique ID. If you have a unique ID attribute, like this one here has the unique ID search form input homepage, we can make a selector for that ID, and then build a locator with that ID. Easy peasy. If you don't have an ID, you can do things like, well, maybe I can write a CSS selector. Just like regular CSS for styling, you can write a CSS selector of the same syntax for pinpointing elements on your page. You can also use Xpath. Xpath is a bit of a sledgehammer. If y'all have used Xpaths before, it's like that double slash and then the attribute name, then more slashes and dots. Nice thing about Xpath is you have functions that you can pop in there. Cool thing about Xpath, it is more powerful than CSS selectors because you can uniquely identify any element on the page with an Xpath. You cannot always uniquely identify any element on a page with the CSS selector. But those tend to be the top 3 kinds of selectors that people use traditionally, whether it's Selenium, Playwright, whatever. IDs, CSS selectors, or Xpaths. Playwright also has some more advanced selectors. For example, if you had a button that was named something like login, you can use a text selector. Text equals login. Pop the text in, and Playwright will look at all the elements on the page for one that has the text login. Pretty powerful. Selenium doesn't do that. If you are using React or Vue as your front-end framework, React and Vue have some particular special locator or selector syntax for their own little special projects. Playwright supports those syntaxes as well. So you have a lot of ways that you can come up with locators. My recommendation on locators, write the simplest locator you can that uniquely identifies the element on the page. IDs are a lot simpler than very long Xpaths. Another thing is, don't like, I don't know if it'll do it here. Let's see. I know some tools, it's like you can right click on an element and then like say, give me the locator and have like Chrome or whatever tool you're using auto-generate locators. 9 times out of 10, those locators are garbage. Always write your own. So if you want to learn more about how to write good locators, there is a Test Automation University course entirely about different locators. So if you want to really get deep down into what it means to write advanced XPaths or CSS selectors and stuff, take this course, totally free. I developed this, yay. But typically what I found when I'm doing this workshop, when I give it to testing people, they already all know about locators, so it's no big deal. But when I give it to people like Python folks, a lot of times some of the folks might not be as familiar with testing, might not be as familiar with locators. And so in this workshop, I typically just kind of give the locators. I don't go through this whole song and dance of inspect and scrape every time. But I do want to kind of walk through it once so that y'all can see how we get locators, if that makes sense. So if you're already comfortable with this, awesome. If you feel like you want to learn more and brush up, you've got resources. Question?
It's only at work recommend data tags over IDs.
You can. 差不多可以, no problem. I mean, if it's your practice that you stuff data tags in there for uniquely identifying things, and that's what you want to roll with, no problem. That is a very easy CSS selector. Yep. A lot of times what I have found, unfortunately, is that in a lot of teams, developers and testers are kind of separate. And so when testers have to come in, it's going to be the tester's responsibility to automate. They kind of have to deal with the page as it is. They don't always get the privilege of like being able to make sure there's IDs or make sure there's data tags. So if you can collaborate with the people doing your automation, or if you're doing the automation, then you can do smart things like that to make it easy. You know, all the locators in this app are going to be super easy because Duckduckgo is super awesome, but that's not always the case. So, yes. Does Playwright give me the opportunity to do what? I'm sorry. It's like if they need to verify a... Yeah, so like typing in your username and password? Or just your certs in general. Yeah, so you can, within your browser context, you can slap on authentication stuff like that, like headers or cookies or whatnot, or certs, so it just kind of goes through. Or you could do it the old-fashioned way of like type in username, type in login, or type in password, hit login. There's ways you can handle that, yes. He's good? You seem a little skeptical. Okay. Sorry. Pardon me. All right. So let's take our ID and let's make this interaction happen. So what we're going to do is we're going to start with the page again. We're going to say page.locator. And in parentheses, we are going to put ID equals bam. What this does is this will create a locator object using the selector, and the locator will be what is used to fetch the element on the page. So this is not like an element object. This is a locator object. This is essentially a pointer to an element. You can create locators at any time. It's only when you call them with interactions that they'll actually go to the page and try to do something. So we've got the locator, and what do we want to do to that particular element? We want to type something in, right? So is there like a type? No, that's not it. Is there like a send key? No, that's not it. There's a method called fill. What we want to do is we want to use the fill method to send our search phrase, panda. Boom. So we have a small separation of concerns here. We have structure of the page versus interaction on the page, right? But this will essentially do that typing for us. Sweet. Alternatively, you could do this command, page.fill. Oh my gosh, you mean I don't have to create a locator object directly? I can just say page fill and do it like this? Yes, yes, you can. You can use one method instead of two. However, I recommend not doing it that way. I recommend splitting. Why? Separation of concerns. Plus, when we refactor this into page objects a little bit later, it'll be easier and cleaner. So in fact, the Playwright team today recommends strongly that you go about it this way. And even though this is still supported in the syntax, they recommend that you do not do it that way. Okay. So we enter the text. What else do we need to do? We need to click the search button so it actually submits. So to do that, page.locator is going to be another locator. I'm just going to give you the ID. It's ID equals search button home page. Any guesses as to what this method's going to be? Click. Boom. Ta-da. Alrighty. Who wants to run it? Yeah, let's run it, see what happens. And again, I'm going to use headed and slow-mo. It did the thing! Sweet. It didn't check anything when it was done, but it did the thing. We have our interaction part covered. Now all we got to do is the verification part. So, yeah, if I shrink my terminal down a little bit. So far, yep, we've got the first two steps done. Our test case should look like this. Cool. So, we are now 1 hour into our tutorial. I would like to stop for a little break, if that's cool with everyone. Before we break, are there any other questions folks have? Nope. Okay, cool. So, how do we feel about like a 5-minute break? That'd be good. Stretch legs, maybe hit the head. Alrighty. So, Apple time, 2:40 Mountain time. we'll be back in here and we shall implement those verifications. We're good to go? Hi, everyone, again. Welcome back. How are we feeling? Good? Are we excited? Yeah, awesome. I'm feeling pretty good. I had a rough morning getting here, but I'm feeling all right. So before we jump back into the verification part of testing, I just want to say I have some cool stuff for you if you would be interested. First of all, I have a bunch of Playwright stickers. I got these directly from the Microsoft team. So I have way more than I need for myself or even this class, so feel free to take as many as you like. I also have my own Pandy Night Automation Panda stickers. These are usually popular with kids. Oh, look, it's so cute, right? So yeah, feel free to take some of those. And also, I have some swag from the previous conference I was at in Orlando. So like I said, I am with Apple Tools. I'm a developer advocate. I do all things testing, automation, not just visual testing, but I'm very passionate about doing high quality work, and that includes testing and automation. And so I just gave a talk, which I entitled Making Great Waves, 8 Software Testing Convictions. And the theme of that talk was I hold certain convictions, things like shift left and right, automate, prioritize your work based on risk. But I compared that to Japanese woodblock printing. Everybody probably knows the Great Wave. Unfortunately, all my Great Wave prints are gone. So here's Red Fuji instead. But I've always loved these prints. They're very cool. They're very colorful. Here, so I've got like a kabuki actor, and I have the Matsumoto frog. Look at this good boy. Isn't that just amazing? Right? I got some other stuff here too. Geisha, plum trees. But anyway, my talk was we can learn things from the ukiyo-e Japanese woodblock print artists and how they approach quality into how we approach quality as software engineers. Because testing and development are as much an art as they are a science. So I have these left over if you want pictures of red Fujis and cool little good boy frogs, or you want to see what my 8 software testing convictions are, or if you want to scan this QR code on the back and do an Apple Tools visual testing challenge and win a $250 PayPal gift card, feel free to come up and take these on the breaks. Please make them disappear. Enjoy the art, enjoy the convictions, and enjoy the little hackathon there. So, cool. Any questions about that before we get back to this? Nope, I didn't think so. Cool. Alrighty. Let's do some verifications. Oh boy, and let me get my own little code back. We're now in part 3 of the tutorial. So, as we said before, when we perform a search, what we want to do is we want to look for certain things on the page, right? We want to get like the search bar text, we want to get the title text, and we want to get the, pardon me, scrape the links and get the text there. So really we have 3 main kinds of assertions that we want. First one we'll do is the search result query being the phrase. So that was, making sure this bar up here has whatever we typed in on the other page. How we're going to do that is, well, I want to do something like, I want to say, okay, I know I need to get that element off the page. So I'm going to need to use what to get elements on the page? Locator, right. So page locator. And again, I'll give you the ID. You can scrape it from the page if you want. Oops, I don't want to use CSS. ID equals, get out the way, search form input. And what do I want to do once I get this? What am I trying to obtain from it? I'm trying to obtain its value. Let's see. It's input value. Okay. And then what do I want to do? I got the element I want. I got the value I want. I want to do what? Sorry. Compare it to. Okay. Equal Panda, because we can use the equal equal operator for strings in Python. And I probably want to make this an assertion. We know in pytest that we use the basic Python assert command, right? Unlike unit test, you have to use the unit test assertion library. Pytest has assert statement introspection, which is pretty awesome. And so this would work. This would get the job done. This is not the right way to do this in Playwright. What? What? For almost all pytest test automation, this would be the right way to do it. But there is a bit of an issue here. And that is that if we were to do something like this, it doesn't fully handle weighting appropriately. We've, up until this point, taken weighting for granted. Now, what do I mean when I say weighting? I've mentioned this before. Ultimately, what we have when we're doing this style of black box test automation, not unit testing that has direct access to code, but black box meaning it's trying to interact with some live system under test. Any type of black box test automation, whether it's REST APIs, web UIs, mobile, command line, what have you, you always have a risk of race conditions. Why? Because the app under test is doing its own thing by itself, and the automation process is doing its own thing by itself. And so anytime you want to interact with the application under test from the automation, you need to make sure the app under test is ready to handle that. The classic race condition that happens with web UI testing is, I try to click a button, but the page hasn't loaded the button yet. And so it tries and it's not there, right? Could also any other, like you're trying to scrape text or whatnot. If you've done Selenium WebDriver, I guarantee you've hit that issue before. And it's very painful. And you're like, ah. And the thing that makes it really painful is sometimes it works because the page loads fast enough, but sometimes it doesn't. And so what we have to do that's really annoying is that for every single interaction, we need to make sure that it waits for the thing before we do it. If you're using Selenium WebDriver, those must be explicit weights, meaning you have to add a whole nother line of code to wait before you interact, or take chances. Or you set a universal implicit weight, and that is also an anti-pattern. But here in Playwright, we didn't do that, because Playwright is smart. Playwright is modern. Anytime you have a locator in Playwright, and then you do something to it, there's an implicit automatic wait done for you. So even though we're saying, let's say here, page locator fill with text, what's going on underneath the hood is Playwright is saying, okay, I have a locator, which is not an element, it's a pointer. Playwright, by default, will wait for up to 5 seconds for this to appear and become interactable. If within the first, let's say, 3 seconds, this isn't loaded, it's okay. It does a smart wait and continuously check. As soon as that bad boy is ready, that's when it sends the fill. That's an automatic wait, and that's a smart wait. And that's something that is done for you, right? Because expressively, what we want to say is fill it. We don't want to have to explicitly say wait and then fill.
So you said there's a timer by default maximum 5 seconds.
Mm-hmm.
I assume it's changeable?
Yes, exactly. So you can change it for that one interaction, like this. You can use the timeout equals, and it's milliseconds, so I could say I want to change that to 10 seconds. And that would affect only this call. Or you can set a global setting to say, I want to change it from 5 to 8 everywhere by default. Pretty sweet. Great question. So now, coming back down to our assertion. So there is actually some automatic weighting done here, right? Because we have locator, and then it's saying, get me the input value. So the weighting that is done here is this call that I've highlighted will wait for the input element for this locator to appear on the page, and then as soon as it appears on the page, it will get its input value. You might think, okay, well, that's good enough automatic weighting, right? No, because not only do you need to wait for this element to appear on the page, but you need to wait for this element's input value to become populated with your desired thing. Because it may be the case that when it first loads, it's empty, and then it fills the text, right? Oh, it's another race condition. Gosh, dang it. Chances are small, but I guarantee you run enough tests, eventually, statistically, you will hit it, right? Think about this. If your tests if you have some race condition in your code and you're not handling it properly and it causes flaky tests, but let's say it's only like a 0.1% chance of the time it's going to happen. You have 1,000 tests run, you're going to hit it once. Okay? 1,000 tests is a really low number of tests to run for a lot of teams. In my previous company, we would run 1,000 tests within about like the first 2 hours of a business day because we'd have tests continuously running. So, and that is only a 0.1% chance of a failure, right? Usually flaky tests fail more in the range of 1% to 10% of the time. Oh my gosh, it's horrible. And usually the number one reason for flaky tests is not because any particular tool is lousy, it's because people aren't thinking about how to properly wait for things. And in my opinion, a tool like Selenium WebDriver does not encourage good practice around that. It leaves it up to you to do it, so you have to know to do it. Whereas Playwright, 90% of the time, will handle it for you. There's only a little bit of time you may have to do explicit weighting, or you may have to change something to get it to be what you want. And we'll see one of those for this condition here. So, how then do we handle that extra little race condition that I just mentioned? Question?
I actually have a question.
Okay, pause, question.
I'm not a web developer, so forgive me if this is a dumb question.
No, it's okay.
Why are Selenium and even this one, why do they have such trouble with waiting for the page to finish loading?
Okay.
I don't understand why this is a problem.
So the question was, why do browser automation tools struggle with waiting? And specifically Selenium and Playwright. First I'm going to say Playwright, like I said, it provides you the mechanisms and the implicit weighting a lot of time that it works flawlessly. So I would say Playwright auto weighting is not so much an issue. So I'm going to redirect to why Selenium. Something to keep in mind with the Selenium project that makes it categorically different from something like Playwright or Cypress is Selenium WebDriver is meant to be a low-level tool. It is meant to be kind of like the most basic API around the WebDriver protocol for you to drive browser traffic. And so in that sense, if we're talking in granularity, yes, you're going to have to imperatively and explicitly do a lot of the types of things. So with a low-level tool, the onus is on you to do the weighting how you want it to be done, right? That's why in Selenium you have to make explicit weights and then do your interactions. The problem is most people coming to do test automation with Selenium don't recognize that. They're told Selenium is the tool you're using, and when they see selenium.click, they think that's sufficient, right? And it's necessary, but not fully sufficient. That's the problem. There's a misunderstanding around how to use Selenium WebDriver as a tool.
I guess what I'm saying is, I have a certain web page I'm thinking
Mm-hmm.
that I have to deal with.
Mm-hmm.
Sometimes really fast.
Mm-hmm.
And then sometimes you might wait 10 seconds.
Yeah.
I don't want to have to put in a slew, essentially, or a
Mm-hmm.
timeout that's 30 seconds just to make sure I cover all cases. Why is it that these things have such a hard time to know when the page is done, it's fully loaded, then deal with it?
So when it comes to the timeout there, I have had that situation where sometimes it's really performant. Another day you come in and it's like really heckin' slow, right? Setting a timeout is a necessary evil for any sort of black box testing, because ultimately you have to have a give up point. So you can't avoid that. What I like to do when I design projects or solutions or pick up a tool is make sure that you can have a way to globally tweak a timeout such that if today, we know somebody blew up our staging environment, today I'm going to dial it up to 30 just to punch through for the functional testing. And then We'll monitor it, and then once they fix it, dial it back down to 5 seconds, right? Popping it in here as like a parameter would be like if you know this particular view or this particular page is going to be longer because we just know that particular one and all the web app loads gigabytes of data. That's when you would do this technique. Does that make sense?
So you brought up something.
Mm-hmm.
So it's not a sleep. It waits. It will.
Correct.
It will react as soon as it can.
Correct. Okay. Oh, I saw questions back there, but let me explain this point real quick. Let's dispel that. Hard sleeps in test automation are a horrific anti-pattern. That's another nugget I want you to tattoo to your arm and take home with you today. Never use hard sleeps. Never do a time.sleep and put seconds in there, right? We have slow-mo to help slow it down if we need to. If you want to wait for something, use these smart waits. The way these implicit weights and smart weights work is the timeout by default is 5 seconds. That doesn't mean it waits 5 seconds for every single interaction. It means it waits up to 5 seconds. It's up to 5 seconds of as soon as the thing enters the ready state, it stops waiting and moves on. It checks repeatedly for up to 5 seconds before giving up and saying I'm done and yielding an error. So we always want smart waits, and we want auto waits, which is what Playwright provides. So I saw 2 more hands go up. I think the gentleman in the back and then the gentleman in row 2. Okay, you're good. So, next question.
So if you have a slow-loading page, and maybe it has like a spinner or something else that indicates it's busy, can you have Playwright wait for that to go away?
Yes. So the question was, if you've got a slow-loading page with some sort of like spinner or something, can you make Playwright wait for that to go away? Pardon me. The answer is yes. There are various ways you can do it. You can check for certain events on a page. You can, if the spinner's a particular like element on the page, you can say like wait. There's an explicit type of wait we can do in Playwright. We'll see in a little bit. We could tailor for something like that. So going back to something I kind of mentioned out of the side a little bit earlier, probably about 80 to 90% of the waiting you need to do will automatically be handled for you by Playwright if you're doing the right things. Only about 10% of the time will you need to make an explicit wait. But when you need to make an explicit wait, like what you're talking about, there are ways that do that to make it easy. Good question. Any other questions? This is good. Okay. So let's come back to this assertion here. So we said we wrote it the way we would typically think to write an assertion in pytest. Then we realized, oh wait, there's actually 2 race conditions in there buried, and this handles one but not the other. So now we're asking, well, how do we do it right for Playwright? And what we need to do for Playwright is we need to import a special function. So let's go back to the top here. From Playwright Sync API, not only do we want to import page, we want to import a function called expect. What's this going to do for us? So down here, I'm going to rewrite my assertion. Instead of this, I'm going to say expect, parenthesis. And inside those parentheses, I'm going to put my locator object. I'm going to get rid of all this stuff here. So expect, parenthesis, target object being my locator, close that parenthesis, dot. And after the dot, I'm going to put the name of a condition to be met. Now, as you can see with autocomplete, we have lots of conditions. Not to be checked, not to be disabled, not to be editable, and of course there's going to be the to be versions of all these. So on and so forth. The condition I want is, I want it to have the value of my search phrase panda. This is what we call a web first assertion. This is one thing that makes Playwright pretty cool. This assertion will not only wait for this element to appear on the page, but it will also include a wait for it to have this particular value. So it's waiting until the final state is reached that we want. This is the safest way to do this. You could get away with that old assert version that we used, but it is not fully correct because it still has that tiny little chance something could go bad. Question?
Sorry, George, you said this. If you don't provide a timeout, is timeout infinite?
Ah, yes, if you don't provide a timeout, is the timeout infinite? I hope not. Default timeout is 5 seconds. But you also bring up a good point of well-designed test automation solutions absolutely need a timeout somewhere. Infinite timeout means it spins forever. It means your CI job never ends. That's bad. Timeouts are safety. Good question, though. All righty. Any other questions? This is good. I like this. We're all engaged. Okay. So let's run this again, make sure it works. Oops, there we go. Same old song and dance. Boom, 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 boom. And we're passing still. Good, 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 good. Everybody able to get this to pass okay? Nice. Alrighty. Let's move on to the next assertion. Checking if the search result links pertain to the phrase. So this was the one where we said, let's get all the result links and try to do stuff to it. Unfortunately, this one is going to be a bit more challenging because we're dealing not just with a single element, but we're dealing with a list of elements, right? Can Playwright handle this? Yes, it can. Otherwise, we wouldn't be here doing this, right? Oh, yeah. Can it do it? No, it can't. We got to move on now. No, it can do it. So ultimately, what we want to do for this, pardon me, we want to scrape all of the hyperlink titles off of this page. There should be a list of about 10 of them or so. Sometimes it might only give us like 5. But we want to scrape all those titles, or we want to scrape all those elements. From the elements, then, we want to map that list of elements found to their string titles. So we get a list of strings that represent all the titles. And then what we want to do is we want to go over that list and make sure that the strings in that list somehow contain the string substring panda, right? As we can say, well, if every title has panda in it, then we know that we got it right. I would recommend even further, not that every link contains the word panda, but that in the worst case, at least one of them relates to panda. It's a very weak assertion, but in this case, this is really nothing more than like a smoke test where we're dealing with uncontrolled data. And so the caveat is, if you have a weak high-level test, make weak high-level assertions. We're going to parameterize in a little bit, and some of the other phrases we have don't always line up nicely, because these are live results. I don't have this like as some mocked thing behind here. So when you're dealing with that, weak assertions. So what we'll do is we'll just make sure that at least one of the strings in our list of titles contains our search phrase, and if it does, we're going to call it good and move on. Sound reasonable? I know it's not ideal, but this is the thing we have. This is also a case for why you should control your test data. If you can control your test data, you can have stronger assertions. So let's start to bang this out here. I'm going to have to bust out our elite Python programming skills. All right. So, oh shoot, let me go back to here. So we will inspect. This selector is going to be a bit longer, but I'm going to give it to you here. Dot result. That's tiny. It'll appear bigger on the Visual Studio Code. So just bear with me a moment. But I want to show you something here. So result underscore title. A dot result. Really? Hold on. Refresh this page. Something's not right. There we go. try that again. Okay, there we go. So what I like to do, especially when I'm dealing with lists of elements, I like to make sure that whatever selector I'm using is getting the elements I intend. So here, each of these result links has, the header has the result title class, and then underneath of that, there's a hyperlink with the result A class. And I can see there are 10 on this page. So I know I'm getting a list of things. So if I want to get that list of elements, what do we think I'm going to be typing in? Page dot what? Locator, yeah. In this case, I'm just going to, since this is a CSS selector, we can just pop that in. Don't need to say ID equal or text equal or CSS equal. We can just, it'll figure out it's a CSS selector. So the first thing I want to do is I want to make sure that these links all appear on the page. When you're dealing with one target element and you're sending commands to it, you can rely on Playwright's implicit automatic weighting because that one is either there or not. But when you're waiting for a list of items to appear on the page, what could happen, right? The page could load the first one, wait, load the second one, wait, load the third one, wait, because it's slow. How do you know when it's done? You don't. It's the halting problem. It is I'm not joking here. Look up halting problem. It's from Alan Turing. This is a fundamentally unsolvable computer science problem. You never know when it's done until it's done. So in this case, we never know it's loaded until it's loaded. So what we want to do is we want to say, hey, I know it's going to give me multiple. I want to wait until a certain number of these elements appears on the page so that I can make sure that I'm getting a list with something in it. Because if you just say, give me the list at an instantaneous moment without forcing an explicit wait, if the page hasn't loaded, you could get a list of 0 elements. And that's no bueno. We want to make sure it waits until a certain number has appeared. So what we can do for that is on top of our locator, because we know this is going to return this locator query will return a list of elements, we can specify a particular, we can refer to elements in that list of, we can refer to items in that list of elements by index. That's what I'm trying to say. So if we wanted to wait for, say, 5 elements to appear on the page, I could say .nth 4. 4, I thought you said 5. 0 indexed. 0 is 1. 1 is the second index or second element. So 4 would be the 5th element in that list. So what this is doing is say, hey, that locator is going to give me a list of elements. Give me the 5th one. And what do we want to do on that 5th one? Wait for it. Boom. Theme. Done. This line is an example of one of Playwright's explicit weights. Typically, you will be using explicit weights, not for when you're dealing with one element at a time, but usually, moreover, when you're dealing with multiple elements at a time. Not always the case, like that spinner example someone asked about before. But, like I said, most of the time you can get away without having to be explicit about weights. But if you need to, like in this case, you can. So this, in plain English, will wait for the 5th element of that list of elements to appear. Boom. Now that we have those elements rendered on the page, we know in terms of execution, after this, there's going to be at least 5 elements, if not more. So we can safely move forward to scrape those elements. So what do I want to scrape from these elements? The text, right? The titles. Very good. So I'm going to say titles equal page.locator, and this is just a copy paste. Oh, copy paste, that hurts. We'll get back to that later. just roll with it for now. I know it's not dry. We're going to fix it. But now we have another challenge. You know, if this were a single element, we could say something like text content, right? And we get the text content of that. But this is going to return a list of elements. So we can't get the text content we can't use the text content method to get all elements. Or we going to need to do like a list comprehension here and map all the things. Yeah, make like a for loop. That's painful. No. Playwright has a function for this, or Playwright has a method for this. Locator, all text contents. So if you have a list of elements and you want to get the text for each one as a list, boom. Amazing. I love it. Y'all are probably like, man, Andy, you get like so excited over silly, trivial things. But believe me, like when I have worked on large Selenium WebDriver projects. That does not exist in Selenium WebDriver. I have had to implement that in a reusable way in a framework I've built. So the fact that Playwright gives it to you for free is like, it warms my heart and soul like a bowl of Quaker oatmeal. Wilford Brimley, rest in peace. Some people got it, thank you. You have the diabetes. Oh my gosh. Yeah, he passed away about a year or two ago. Broke my heart. He was always a good guy. So, anywho. So now, okay, we have a list of strings that has our titles. Next step is let's check that list of titles to see if it has our search phrase in it, right? So what I would like to do as the next step in that is to filter down for all of the matching titles. So we can do something like this. Matches equals, and I'm going to do a list comprehension. Most people, I'm guessing a lot of you probably have used list comprehensions, but maybe not some. Real quick, brief thing, list comprehensions are an intermediate to advanced kind of Python technique. But basically what you're doing is it's list-based operations. So you can either take all the stuff in a list and for each element somehow transform it into something else or map it to something else. Or if you have a list of elements and you're trying to filter it down based on some criteria, like does it have a substring, you can filter. We are going to be doing a filtering list comprehension here. The syntax is going to look like this. So T for T in titles. What this is going to do is say, hey, pick some arbitrary, or iterate over the list of titles, and each iteration, you're going to store that value in a variable called T. For T in titles, and the filter is if, and now we're going to put a condition. If my search phrase panda is in, meaning a substring, of that title, and we're going to be safe about it, I'm going to make that title go to lowercase. That way, if it's capital P panda, it'll lowercase it, and then we can check it against our search phrase. And so ultimately, what this will do, matches will contain all of the elements in titles that contained the phrase panda. Make sense? Cool, yeah. List comprehensions are awesome. If you do C# programming, it's very similar to LINQ. Question?
Can you put in a breakpoint?
Can I put a breakpoint in?
The test. So I put in a breakpoint and it just walked up. I had to Control-C to get out of there.
I want to nuance this.
Just
Just in general in a test case. Yeah. Okay, so yes, question, just to repeat for the thingy-jig. Can you put breakpoints in your test cases? The answer is yes. I've done it before with Visual Studio Code. I think there's like a special way you have to do it to set it up there. I know PyCharm, it's very easy, but it should, like, it's very helpful when I've done debugging. It's like you set a breakpoint and then you just kind of run to that point, it does the thing, and then it kind of freezes your browser open. If you've got it like indefinitely hanging or something and not moving forward, I don't know. maybe there's some weird Playwright edge case that went wonky. Maybe there was some issue in your editor or setup or something. But The general answer is yes, Breakpoint should work with this. If it doesn't, I don't know. Sorry. Also, I should use that to bring up another point. If you ever get stuck with Playwright, you can go to the Playwright Slack room and ask for help, and the Microsoft team is very quick to respond. Most likely, you will get quicker and better help if you ask them than if you ask me, unless like we're one-on-one. So I strongly recommend join Playwright Slack if you're picking this up to do projects with it. Their docs are really good. Go to the docs first. If you can't find it there, go to the Slack. Hey, I need help with this. And somebody going to be like, well, and you're like, oh, thank you, that worked. So, and they're active. Like, you do get help. It's not like screaming out into the void. Okay, so we have our list comprehension done. We have the matches list now having all of the strings that contain our search phrase. And so finally, we can make our assertion. And the assertion we want to do is we want to make sure at least one of those had a match, meaning assert length of matches is greater than 0. Does that make sense? Yeah. Now you might be going, well, Andy, don't we need that fancy expect function in here? In this case, no. This case, we got what we needed from Playwright, and this was all race condition safe, thread safe, all that. So we got data in a safe way. And really, all this was doing some manipulation on that data to get it into a state where we could do some meaningful checking. And so this check is really just a plain old check. And so we can safely use an assert here, and we're good to go. All right. So as always, let's run this test case and make sure it works. Please work. Woo! Still green. All right, everyone else got a green test case? All right. Okie dokie.
So mine failed because it said all test contents was a method, and you're not calling it. Oh yeah, there you go. Okay, it was just cut off.
Oh, sorry. Yeah. To be fair, I think I did call it a method when I was typing it out. No worries. No worries.
So mine failed for an interesting reason. I noticed when I was looking earlier at the search results in Firefox,
Mm-hmm.
also in Chrome, I saw it in both places, that sometimes I would get the classes that you have here, result title and a.result A,
Mm-hmm.
and then other times it's like they're doing A/B testing or something.
Oh,
Because I was getting classes that were gone, and instead they were using the data fields instead. So sometimes it worked and sometimes it wasn't working.
pain in the
And I
butt.
didn't refresh a bunch of times, and sometimes that's how it went. Sometimes.
Shucks. I'm sorry.
So just a heads up.
Yeah. Well, okay. So yeah, this is why you control your test data. This is why you have controlled environments. The reason why historically I've used Duckduckgo is because it has been fairly consistent, but sometimes you get stuff like this and it's like, oh my gosh. Like originally when I had done talks and tutorials around this type of thing, I used Google and then Google would mess with me all the time. I'm like, screw that. And I'm going to DuckDuckGo and DuckDuckGo is consistent for a while. Now you're telling me it's screwing up. Sorry. Good. Another thing that I have seen, and this is, again, particular to DuckDuckGo, if you run headless mode, it may just freeze you. And the reason why, I'm pretty sure, is that DuckDuckGo senses that that's a bot, and they don't want to serve it. So like usually if I just run like one headless run or two, it's okay. But if I do multiple back-to-back, or if I try to do a lot of headless in parallel, it's like, oh, no, you're a bot, stop. And then my test will fail after 30 seconds for the universal timeout. I'm like, oh, gosh. And But headed mode usually works for me versus headless. So, yeah. Sorry if you hit those troubles. If you hit it, just do it again and note the caveat. I wish I had a better application I could just give you, but then that complicates setup. Yeah. So anyway, barring some sketchy A/B testing or bot blocking, this should work. Okie dokie. So we have one more assertion to do. And this one is for the page title, right? The page title was that little thing at the top. The page title is not an element on the page, it's an aspect of the page. So in this case, what we want to do is we want to get the page title and make sure it has pandas in it. So we could do something like this. You know, we could say assert page.title, or we could say assert panda in page.title and do something like that. But we also know there's a race condition there. What if the title hasn't synced yet? So the better way to do it using a web first assertion is not this, but using our expect. Expect page, and then so we have assertions not only on locators, but assertions on pages. To have title, panda at Duckduckgo. Okay, so that is the proper way to do it. So again, it'll do that smart waiting. It'll wait for the page title to sync and all that stuff. Now, one frustrating thing here is like, wait a minute, hold on. Yeah, I know that, or like if you look at the page title itself, this might be kind of small, but it is panda at DuckDuckGo. If you just hover over in Chrome, you'll see that name. You know, that's going to be a full exact match on the title. You might want to just do like a substring check, like to say expect page to contain title. Unfortunately, that is not a available method, but something you can do if you want. You can pass in a regular expression, so you could say import re for the regular expression, and then you could say re.compile r star panda dot star, and then give it the, oh gosh, come on, do it like that. And so that way you can do like a substring check, and it's more powerful. You can do a full regex check. So if you only had a part of the title you wanted to check versus the entirety of the title, you could do something like this. I'm going to not do that, but I'll leave that in comments. And I like simples better than complex, so we're just gonna, since we know what the full title should be anyway, panda at DuckDuckGo. Boom, just like that. Does that make sense, everybody? Question?
Can we use a similar technique for when we match the search results? Using regular expressions instead of
Yes. Yes, you can. That's an excellent question. And yes, to have value, you could put a regular expression in here as well. In fact, let me make sure. I'm 90% sure you can. Hold on. To have value. Yes, so value, string, or pattern. That was one thing that kind of threw me at first, because I was like, I want contains. And then the Playwright guys were like, Andy, just pop in a regex. And I'm just like, you can do that? You know. So yeah, anywhere you see like a to have some sort of string value, it's usually going to be string or regex.
So what about the results? How would we do that practically if we wanted to refactor that into regular?
I mean, you could say get all text contents, and then like your filtering condition could be like if panda matches a particular regex instead of string contains. You could do something like that. I think that's a little bit of overkill. Regular expressions are categorically more complex, therefore categorically more thinking overhead, therefore a little tougher to try to figure out as you're going about. So only use them as you need them. But great questions. I love regex. Be safe with them. Don't do dangerous long things. Alrighty. So let's yet again, one last time, run the test, make sure it works. Yes! Passing. Everyone else got it passing? Sweet! Cool. So, there's one more thing I want to point out about this. We'll take another 5-minute break, and then we'll come back and refactor. But congratulations, you all have completed your first Playwright test. Woo! Give yourselves a hand. Yeah, man, come on. You're like, woo! We did it! Gosh, I know it's the afternoon. We got this. Get some coffee. So, where's my little green pointer thingy? So, interesting thing. Remember I was talking about like the automatic weights and stuff? So, is it showing the, hold on, let me. So, when I first developed this tutorial years ago with Selenium WebDriver, when I wrote my then steps here, my verification steps, I actually made this the first one. I moved this up here, and then I did the search bar, and then I did the result links. Why? Well, first of all, that's top to bottom on the page. And secondly, this is arguably the simplest. This is slightly more complicated because it then adds the locator, and then this is the most complicated one. But when I did that, and I had this up here, and I run my test against Chrome, it would be fine. But then I would run it against Firefox, and it would fail. And the reason why was because Firefox takes 2 or 3 seconds to change that title of the page. There was a race condition in waiting for this title. And I was like, dang it. Sucks. And so I was actually recording video of this tutorial for something. And so I'm like, well, I already recorded the chapter of like doing all the thing, had the code there. So I was like, okay, we're just going to move this assertion to the end because by the time we get done these two, the page title will definitely have loaded, and we'll just kind of like leave that as an implicit race condition that's never ever going to get hit, right? Because if you wanted to wait explicitly in Selenium WebDriver, this would be a much more interesting thing or a much more challenging thing to do. But in Playwright, it has that web first assertion that automatically waits not just on elements, but also on the title. Another reason Playwright's better. And so, what I really ought to have done for today's tutorial is move this back up here to go simple, more complex, more complex. Because I can now do that the way I originally intended, where I couldn't easily do it with Selenium. But then I kept it here anyway because I wanted to point out that example. Question?
Yeah, I hadn't noticed, but which engine are we using in these tests?
Ooh, that's a great question. Oh, I forgot to mention that. Okay, so when you're doing Playwright with Python using the pytest plugin, Playwright Python pytest plugin, so many P's. By default, this is using Chromium. If you don't specify otherwise, it's using Chromium. We can specify other browsers, and I will show you how a little bit later. Caveat, if you're using Playwright in other languages, that may not be the case. For example, if we were doing Playwright in JavaScript or TypeScript, and we didn't specify a browser, it actually, by default, runs all 3 browsers in parallel at the same time. So we would be running 3 tests instead of 1, and on 3 different threads. So that's why I give that caveat. With the plugin, by default, it's going to be Chromium. But good question, good question. Chromium is typically the fastest of the 3 as well. If you have to pick one, I recommend Chromium. Why? Highest market share, fastest speed. Cool, cool. Any other questions for now? Alrighty, so let's take another 5-minute break. Be sure to pick up some stickers and postcards in the front. And let's be back here at 3:38 Apple time. Hello, hello. We're back. Cool. Alrighty. So I saw a whole bunch of people swarmed around the swag. I saw the pandas went missing, so I threw some more panda stickers down. We still have some of those postcards. Please take them. They're beautiful. If y'all are remote or you didn't get a postcard, here's the page for that visual AI challenge I was mentioning that my company's running right now. Basically, what you do is you pick a language, pick a web browser tool or framework, and you follow along with the steps in the coding challenge, submit your results. It's pretty basic, should take you like 30, 60 minutes. Not too hard, just kind of shows you, not only what we're doing today with automated testing, but how to use visual testing techniques. You can submit that for the pure joy of learning, but also if you submit, you get entered for pretty cool prizes. I think we're raffling away 4 PayPal gift cards worth $250 each. So it's pretty significant. I've blown up the link here for this page, appletools.com/appletools Visual AI Challenge, Star East 2022. It was meant for the previous conference I came from, but I'm pretty sure nobody will be upset if PyCon folks joined in too. So take a picture, jot it down, go find it. You have until Sunday, May 1st to give it a try. Of course, you could always give it a try afterwards. You just won't win a prize. So, that being said, let's get back to the playwrights. Okay, so if we look at our test overall, I'm going to push the terminal down just a little bit so we can see a full screen here. Oh, that's as far as it's going to go. Okay. Be as it may, what is it is. Come on, come on. Good enough. So when we look at this code, what do we think about this code? Do we like this code? Do we think it's pretty hot? Do we think there's some problems with this code? Yeah, what don't we like? What don't we like? It's hard-coded with what? Panda? What else is hard-coded? The URL is hard-coded? Yeah. The fourth or fifth? Well, that one, we want to make sure we have a certain number of elements loaded, so we did choose it. It's been chosen. Do we see some duplication? Yeah, selectors, yeah. Overall, I think this code is okay, but the biggest problem I see overall, other than some of the hard coding, is these steps are rather imperative, right? They're kind of granular, they're low level, saying, give me a locator, do this very low level mechanical action, whereas when I think about testing, I think more in terms of what's going on in the comments, right? It's not, for me, a page go-to, it's that I'm loading a page. It's not that I'm doing locator fill, locator click, I'm really thinking searches the page. And we have that duplication problem where these things aren't very reusable. Question?
So in the case where you have a site that has like a testing or something, in like my case at least, like the locator we used didn't work.
Yes.
After like a couple iterations.
Mm-hmm.
Is there a way of passing multiple IDs into the locator?
You can do that. It's not native in Playwright, but you can do some if-else logic there. So the question was, what if when I load my page, okay, so context for the recording and who's ever remote. There was a problem where, because we're using DuckDuckGo, some people were getting stuck in A/B testing where the locators were different. Is there a way that I could fall back on a secondary locator if the primary one doesn't work? Yes, there's a way. You have to implement it yourself. It'd be an if-else. If I try to get this and it's not there, then fall back on the other one. It's not clean. Then again, like I said before, caveat, we're dealing with an uncontrolled app. I'm sorry. And I'm a little ticked because that wasn't happening like 2 days ago. We weren't hitting this A/B problem 2 days ago. I don't know why it happened to be today during tutorial day at PyCon. Go figure. Thanks, DuckDuckGo. If someone from DuckDuckGo is listening, we see you. Oh, gosh. So, where were we? Don't repeat yourself and all that good stuff. Okay, so, yes. When I automate my web UI tests or mobile tests or really any other kind of, well, yeah, web UI mobile, I don't like to use raw calls like this because they tend to, and they're not very reusable. What I like to do is use a design pattern to help improve the reusability and the readability. My design pattern of choice is called the screenplay pattern. Has anyone heard of screenplay pattern? Nobody, not surprised, that's okay. Screenplay exists more in the non-Python world. I have opinions about these things, we can wax philosophically later. But a more common pattern that has a little bit lower barrier to entry and actually works really well with Playwright is called page objects. Has anyone heard page objects before? One person, two people? Y'all Selenium folks know page objects? Oh, okay. Well, we're going to learn more new stuff here. Page objects are not specific to Playwright. You can use them with Cypress. You can use them with Selenium. You can use them with Appium. Page objects are decent. I think Screenplay is better, but we don't have a Screenplay implementation in Python yet, so we're going to stick with page objects. The idea of a page object is rather than have all these raw calls spilled out in a test case, we're going to define classes that represent pages. So in this test, how many pages are we interacting with? 2. The search page and result page. So we're going to implement 2 page object classes, a search page and a result page. Each page object class has a collection of locators that model structure of the page, as well as a set of methods for interactions. So let's build some page objects together. Where we put our page objects, we are not going to put them in the tests directory because page object classes are not tests, therefore they do not belong there. My recommended practice is we create a new top-level folder in our project and call it pages. This should be equal in hierarchy to the tests folder. It should not be under the tests folder. And we are not going to leave this as a directory. We are going to make this a package. And so as we know, in Python, we add a file named dunder init, that is underscore underscore init underscore underscore .py. And all of a sudden, now we've turned a directory into a package that we can import other modules. Yay! And we're going to leave this file blank, which always struck me as odd, but we're just going to do that. And it's okay. It's okay to leave that file blank. That is an okay practice. It's not a bad practice and not a good practice. It is a standard practice. You can add stuff in there too. It gets wonky. So in my pages directory, side by side with init.py, I'm going to, oh, wrong one. I'm going to add a module called search.py. And this is where we'll put our search page class. So in the search page class, I'm going to start off by, remember this import of the page type from the other module? I'm just going to copy paste that over because I want that type again. Playwright Sync API, import page, and I'm going to define a class. If classes are new to you in Python, totally cool. These classes are going to be fairly simple. If you're an old hat pro with object-oriented programming, then this is going to be piece of cake. Either way, should be pretty straightforward. If you have any questions, just let me know. We can kind of step through what it means to have a class and an object. So I'm going to call this class Duckduckgo Search Page. Boom, boom. And we are using Python 3, which is beautiful. So in here, I'm going to add some data. One thing I'm going to add as a class variable is the URL. URL equals this. Now, I'm going to caveat this and say this is actually not a recommended practice. Whenever we are doing web UI testing, we are targeting some page, therefore we need some URL to start with. It is a much better practice to pass in any URLs you're testing as an input into your automation, not to hard code it in your code. The reason why is because a lot of times when you're developing web apps, you may have multiple instances of that web app that you could test against. You might have a development environment, you might have a test environment, you might have a staging environment, and yes, you should have a production environment. And really, you should be able to target your tests at any environment and see how they run. So if you hard code the URL for one particular environment, then you can't quickly just switch it to other environments. If you want to learn more about, oh gosh, hold on a second. If you want to learn more about input strategies like that, I'm giving a talk on Sunday afternoon called Managing the Test Data Nightmare, where I'll show you different ways you could pass in data like this into your tests. But because we're not focusing on that, I'm trying to stick more towards Playwright Python, and if I wanted to show how to architect a whole bigger thing, it will take a lot more time. We're going to take the easy path, pop it in here for convenience with that little asterisk to say, hey, don't do this in the real world. Okay, so next thing in our class we're going to do is we're going to make the init method. Def init as dunder init, underscore init. And we all know, yeah, it's like a constructor, but it's not actually a constructor. It's an initializer, but we're just going to roll with it. It's going to be cool. Self, and the thing that I want to pass in for this constructor as a form of dependency injection, I want to pass a reference to the Playwright page. And init methods return a none type. So I'm going to store a reference to the page, self.page equals page. Cool. And then what I want to do is I want to create instance variables for each locator for things I want to get off of the search page. So search page, how many elements did we interact with? 2. What were they? Search bar and the search button. Yes. So what I'm going to do, I'm going to be lazy. I'm going to copy and paste this over and then make some changes. So what I want is I want that locator. So I'm going to say, I'm going to call it self dot, what's a good name for this? Yeah, search input. Let's call it input because this is an input. That's like the HTML thing. But you could call it search bar. Totally cool. Totally cool. And then this one, I'm going to do this thing. And this one, let's tab it in. And self.search button. Yeah, cool. Okay. Ta-da! Remember what I said before. Locators are pointer objects. So even if this page isn't loaded yet in the web application under test, in my automation, I can still construct this page object with these locator objects way before page ever appears, and it's okay, right? And then we can use these locators later, once the page is loaded, to actually get the things. Okay, so we had how many interactions we were doing with these thingy-dings? 2? What were the things we were doing? We're going to load, and then we're going to search. Yes. Yeah, we do click, but really, click is like a menial level kind of task. But the intention of our step is to search. So let's make a method called load that will load our page. Oopsie. And again, this isn't going to return anything. Loading a page is a task. It does something and it's done. There's nothing to return, it's just do the needful. So how do we load the page? Self.page, what was the name of the method? Goto. Why did they use goto? Why didn't they say something like get or navigate? Doesn't goto like hurt you in your soul? Like didn't we all learn at some point when we were programming, don't use goto statements that's bad? I don't know. That's what, so I learned how to do programming starting in the early thousands. I was in high school, picked up a TI 83 plus calculator, started programming math formulas. This is the best thing ever. Then picked up Java and C++, and I did that whole thing. And at that time, the instruction in programming courses was very much like you learn hello world, variables, if, for, structured programming, and then object-oriented programming. And they always put in there like, goto is such a bad thing, you don't want to use that. And it's like, okay. Also, global variables are a bad thing, don't use that. So that's like, in my generation of learning programming, it's like drilled into my brain. I can't get out of it. Is anyone else like that? Am I the only one? Okay. If you're not, it's okay. It's okay. Maybe, that was either before you, maybe that was after you, and we have so thrown goto in the trash that it wasn't even a thing worth bringing up. That's a good thing. But it just hurts me to see this. I'm like, really, guys? Come on. Or girls? Really, people? Come on, goto. Don't tell the Playwright team I'm bashing that. It's meant to be a joke. It's meant to be funny. Oh, the pain. Because TI 83 plus calculator basic, you had to use goto. And so I taught myself how to program using goto. Then I go to Java class, and they say, don't do that. That's bad. I'm like, crap. Oh, and then I learned, actually, it is bad. Hey. I started learning Python in senior year of high school. It's Python 2, like 4, 2, 3. That's when I got started. Anywho, that's a little bit more about me. Keep it interesting. So, ta-da! Load method. Let's also do a search method. Def search. Now this one, I'm going to make this a little fancier. I'm going to write this such that we can pass in any phrase to search. We could hard code the word panda in here, but if we were to write other search tests, we might want to search for other things like Pikachu, right? Pikachu's pretty cool too. I mean, why don't we want to search for that dude? So generalizing, parameterizing like this is usually a good practice when building interactions like this. So even though we don't necessarily need this for this one test case, it can help for the future. And it's just good practice. Again, this is a task of an interaction. Therefore, we are going to give it a none return type. And in this case, who wants to try to spell this out for me? Self dot, what do I do? Which of these wonderful locators should I use? Search input. Dot fill phrase. Boom. Then what? Self dot search button dot click. Yeah. Awesome. So let's take a step back and look at this. Wow. Congrats, we have just written our first page object. Woo! Awesome. What do we think about this? Do we like this? 喜欢吗? Yeah, I think it's pretty good. What do we like about this? Abstracts a little bit. Okay. It's far more structured, right? We have separated loosely. We haven't fully separated concerns, but we kind of separated concerns between structure and interaction. If you want to fully separate and be solid about it, that's what Screenplay is about. So I would say this is decent. It's okay. Makes a little more sense. Any other things we like about this? Sorry, what was that? It's reusable. Yes. We could use this for multiple different searches. Or if there's other things we wanted to do on the page, we could just add more methods that could then be reusable. I also like that this is self-documenting. Right? Look at the search method. Search input fill, search button click. That's a lot more readable than page locator some ugly gorp dot fill, right?
Also, is that page changes is you only change one in one place.
That's right. So if you're stuck in some A/B testing hell, you can come here and change your locators all in one place, and you know where. Instead of trying to search through every heckin' line of test code through however many test modules and functions, you can be like, I know the one place. I go to my pages package, I go to the search page, and I just change it there and everybody's happy. Yes, yes. Everybody, very, very good, very good. So page objects are decent. They're better than raw calls. So now that we have our page object, let's go back and refactor our test case to use our page object. Oops, hold on one second. Okay. So what we're going to need to do is we're going to need to import that particular object. So from pages.search, import Duckduckgo Search page. Again, that's why we put it in a package so we can easily import it. If you stuff this under your test directory, you can't import it. Why? Test is just a directory, it's not a package. Why don't we make tests a package by adding an init.py? Read the Python docs, or read the pytest docs. They'll tell you why not to do that. Bad things can happen. So, recommended practice, do it like this. So, I got this page. So now at the top of my test case, I'm going to create a page, a search page. I'm going to say search page equals Duckduckgo search page. And remember, we have to inject the Playwright page like that. That's dependency injection in action. And now I can simplify my calls. I can say, instead of page go to hard coding, I can say search page dot load. And here, instead of these 2 lines that are very long, I can say search page dot search, and we'll still put in Panda here. I think it's okay to put in Panda here. This is specification by example. What's specification by example? It shows that you're illustrating behavior that you're testing with real live examples, not some abstractions. Why? People understand it better. So for now, this is good enough. And so just like that, boom, we have used our first page object. Everybody with me? Yeah. So let's run this test again, because we always like to make sure we test things along the way. It's a new type of TDD. Wah-ha-ha-ha. And boom, 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 boom. Cool, we're good. Page objects work. So there was no, oh, am I getting hung up in this A/B testing crap now? Oh, y'all poisoned me. Oh, are we all getting it? Is it like pinging? Are we all in like one shared IP in this location? It's like, oh, we're going to send them on there. Oh my gosh. I'm sorry, friends. Okay, let me inspect this. Okay, who had the better locator for that? There was like some yeah, let me try this one time without slow-mo and see if it does it better. If not, help me out, friends. Okay, it did it that, whatever. Okay, we'll just, sorry again. It was not doing this like yesterday, I promise. Anyway, so page object worked. So page objects don't change functionally how something works, but it helps us write better tests. Why? Readability counts. If you do your page objects right, you may not even need these comment line given when thens anymore, because your test code may be so readable, it's just as if you were almost writing plain language. You know, the way I explain Python to non-Pythonistas, especially like people in my testing communities, Python is kind of like executable pseudocode, and it clicks with them like, oh, right? So do it well. You may not even need to keep those given when thens. I will keep them because I like them. I think they're pretty. I think they still help, but if you want to, you can. Alrighty, so who's ready to make a result page? Oh no, some people are not excited about writing another page object? Oh, you're breaking my heart. It's okay, I'd rather write screenplay calls too. I understand, but we're gonna do page objects because they're a little easier for this application. Result.py, new module. We're gonna copy that import statement again. And then, oh, there's another thing we need to import because we're going to be dealing with lists from typing import the list type and just roll with it.
Do you have to do that anymore?
Huh?
Do you have to do that anymore?
I don't know. Maybe not. We'll find out. I thought I did.
Yeah, just lowercase.
Oh, I can do this. Oh, well, I just learned something. I don't have to use it at all. Oh, well, damn, oh, nice.
And then if you're in earlier versions, you can do from future
Sweet.
and it allows you to do that regardless.
Awesome. And this is why we do pair programming and code reviews. So we learn from each other. Because, yeah, even though okay, another sidebar. I know I'm up here on stage and I'm doing this thing and I'm like pandificating about all these good testing practices. I'm still learning stuff too. So don't feel like, just because you may feel like imposter syndrome or you feel nervous or you feel like maybe I don't know as well as I can, you still have value to offer to help others. Mic drop. Yeah. Okay. It's what it means to be part of the Python community. You can use Python, but when you're part of a community of Python, like coming to PyCon or PyOhio or whatever Python conference you want, or going to your local meetup or getting involved online, right, makes it so much better and so much more valuable and so much more helpful to everybody. That's why even though I don't use a whole lot of Python all the time, I still do quite a bit. I still love to come to the Python events in the Python community to have this, because Python community is awesome. Oops, sorry. Duck. Okay. It's not dry, it's just duck. Okay, Duckduckgo result page. Are we having fun, y'all? I'm having a blast. It's kind of hard because everybody's kind of heads down on code. I'm having fun up here. I was afraid this was going to be painful. This is a lot of fun. I hope y'all are having fun too. And if you're watching the recording afterwards, I hope you're having fun at home. Okay, so what do? Same kind of thing. Okay, so we're going to make a init method again. Init. Whoa, it did the autocomplete thing. Nice. I'm going to need page. Oh, yeah. Okay, so page. Self.page equals page. And again, we're going to do our locators. So the locators that we were using for the result page, we had this one here for the search form input. So self.search input equals that. And then there was also the this one for the result links. So I'm going to copy that over. Self.result links equals this. And there we go. We have our initializer. Now, one thing I'm going to nitpick here, and I should go back and do it on the other one as well. Something I like to do in my page objects, I like to alphabetize my locators. That makes it easier for me to find. It may seem kind of trivial, it may seem like a nitpick, but I have worked on page objects that have had dozens and dozens to hundreds of locators. I have worked on page objects that have extended into thousands upon thousands, even tens of thousands of lines. I'm not saying that's right. I am, in fact, saying that's categorically horrible. You should not have page objects that big. But sometimes you're working on projects where you don't have the agency to make it better. So in that case, I like making them alphabetized so they're a little easier to find and you can mentally map them out a little better. Okay. Now, this page object is going to be a little different than the other one. I mean, of course, because it's a different page, but I mean, in our approach to implementing our interactions. On the search page, we were doing nothing but tasks. Do the needful, don't return anything. However, on the result page, we're not doing tasks. We're asking questions, right? We're asking what's in the search bar, what's in the title, what are the result links. That's a fundamentally different kind of interaction because it's querying state on the page, asking a question, and then returning that result or answer. And so, and then what we do with those answers is we make assertions upon those answers. Everybody with me? Why am I digging into this so deep? Because we need to maintain a healthy separation of concerns here, right? The concern of performing an assertion is separate from the concern of querying that state, of asking that question. We should never, and I mean never, embed assertions into page objects. I'm going to say that again. We should never, ever bury assertions in our page objects. Don't do that. You might be, why? Why wouldn't we do that? And why am I banging on the table about this? First of all, bad things have happened. Everything I'm telling you is because some bad thing happened in my life. I want you to not have to suffer like I did. But anyway, specifically, why this one? Whenever you're asking a question to get an answer, the goodness or badness of that answer is contextual. So, if I'm searching for pandas, how many result links do I want to relate to come back and relate to something related to pandas? At least one, right? I want something, right? What if I type in an absolute garbage string and I query the page, or ask the question for the result links, and I get back nothing, empty list? In that context, for that test, empty list is good. But in the context of the panda test, empty list is bad. It's the same question. It's the same interaction. If I were to embed my assertions in those calls, I'd effectively have to duplicate the code to make the interaction just to have separate true falses for assertions at the end. That is why we separate our concerns. It makes it more reusable. So always keep your assertions in the test function, in the test case, because they are test case concerns. And offload your questions and your tasks to your page objects separately. Does that make sense? Okay, good. Foundations of good testing. I told you, you came in here thought you were learning Playwright. You're actually learning all the best things about test automation. Ha-ha, success. And you learn Playwright along the way. Yes, ha-ha, success. Blowing people's minds. I hope y'all are learning good stuff. I'm having fun learning, teaching, and all that. So, in that case, we're going to make sure in our approach, we're going to keep the assertions in here. So really what we want to do is we want to kind of separate out these other pieces and kind of move them over. Now, if we were doing Selenium-based page objects, there's a whole, we would probably move all three of these things. But with Playwright, we also have to remember that the web first assertions are very much tied to, like the locator objects themselves. So if I'm looking at this here assertion, expect my page locator of this thing to have a particular value. I mean, just textually, we know the expect is ought to stay. We know to have value ought to stay. The locator is the only thing that we really need from the page objects, right? In this case, we don't need to write a method to ask a question. We just need to make the page object, make that locator available for the assertion to do its thing. Interesting. So in this case, what I'm going to do, let's import from, let's do it alphabetized. I'm going to be picky. From pages, result, import, Duckduckgo result page. I'm going to do the same thing. Result page equal Duckduckgo result page. And so down here, all I'm going to do is I'm just going to say, hey, you know that locator result page dot, what is it? Search input. There we go. Autocomplete, yay. So now when we read this test, it's like, if we try to read this line in plain language, it's like saying, hey, expect the result page cert result to have the value panda. Does that look like code to you? That's like plain language to me. That's one thing. That's another thing that makes Playwright really, really cool. With his assertions and his formatting like this, it reads a lot like plain language. So I'm just going to leave that search input purely as a locator. I don't even need to write a method in my result page to do anything with that. I just need it to specify page structure so that I can call it in the assertion here. Now, if I look at this thing, this is a little more complex, right? Simple is better than complex, but complex is better than complicated. I would say this is complex, not complicated. So we know here we have what we're trying to do. First of all, we are trying to get a list of titles from the page. We're asking for a list of titles, right? That's a question we're asking. And then the second thing we're doing is we are doing a data transformation, right? And then the third thing we're doing is we are assessing a Boolean condition, which is kind of like asking a question that's indirectly on the page. We could kind of wholesale move this off into one method in our page objects, but I kind of want to split it in two, and I want to split it into here. So let's do that together. So first function, result link titles. Self. And now this time I'm going to have to return a type because we're asking a question. And so it should be a list of strings. Oh, yeah, it's pretty nice. I learned a thing too. All right, so I'm basically going to wholesale copy and paste and then simplify. So page locator, this thing should be self.result links. And we still need to do that nth and that wait for. But then down here, I can say I want to return the list of titles we get. So, and again, it's going to be the same locator that I'm going to reference again. And now here's the first time we see the value of having a locator here and reusing it. Longer your pages, the more you're going to reuse these locators. And so return self result links all text contents. And this, to me, looks a whole lot better than this. Now, let's make a second method. Like I said, we could combine them in one. I want to do them separate. Why? Because I made a design decision. Testing is as much art as it is engineering. This one, I'm going to say def result link titles contains phrase. Huh? What is this? So self, and I'm going to pass in a phrase that is a string. Oops. And this is going to return a Boolean. Oh, shoot. You might think it's odd. Okay, why are we phrasing it like this? This is a type of question that is returning a true-false value. It's assessing a condition. It's not performing the assertion, but it's setting up for the assertion. This is like the setup, and the assertion is going to be the spike. And like I said, that makes it more reusable because I could assert either true or false depending on my context. Another thing I want to add in here, instead of hard coding that is greater than 0, we can actually include a minimum value. And by default, we can set that to 1, but we can override it if we want. Why? Reusability. So what goes on in this method? First of all, I want to get those titles equals self.result link titles. Oops. And then I want to say that matches thing. Matches equals this. And titles if my phrase dot lower in t dot lower, because I don't want to hard code that panda anymore. And then I'm going to return the length of matches, and it's not going to be greater than 0 now, it's going to be greater than or equal to the minimum. Okay? So a little more robust than what we had before. Okay? And likewise, we can come back over to our search test. Just wait a moment for people to finish typing. Yes, question?
Does Playwright do any kind of lazy loading? So if you call result links, don't have to wait for twice, will it recalculate the same value twice in a row, or is it kind of cache some of that?
I wouldn't know what's going on under the hood precisely, but what my gut tells me is that your page is loaded, the first call is waiting for that thing to be there, and I'm guessing the second time we'd be like, oh, I don't think it would cache, it would probably just be like, oh, let me go check, and it would just happen to be there, and so it'd be like, boom, done. It's an easy check. It uses Chrome DevTools, so it's faster than WebDriver protocol. Okay, so then once we have this, let's go back and refactor our test. So we already did this one. We can get rid of these 3 lines and say assert that my result page dot result links titles contains the phrase panda, and I'm okay with the limit of 1. Don't need to change that. I could if I wanted, maybe in another test, I don't know. And that one's done too. So question, do we need to change anything about this one? Should we be porting this over to result page object? No, what would you do? Yeah, the title is an aspect of the page, whatever the page is. It's not specific to the result page. So in this case, like even though we are checking the title while it happens to be on the result page, this is not something that we should clutter up our result page object with. It's totally cool just to kind of leave this the way it is. Cool, cool. So let's run the test again. Please, A/B testing, don't screw me. Boom, passed. Cool. So we go with page objects? Yeah, alrighty. Tutorial ends at 5 o'clock, right? Okay, so let's take another 5-minute break. Be back here at 4:26. I'll show you how to do a little bit more cleanup with setup, and then also some Playwright tricks. And that should carry us to 5. Back in. Woo! Sound, thank you. Awesome. Okay, so we good with page objects? Yeah, page objects are okay. They're decent. I beat up on them from time to time, but yeah, they get the job done. Enough, usually, unless it's scary. So, here, one thing I wanted to point out is how these things are constructed. Here in this test, we see that, okay, the first thing I did is I constructed my page objects, right? Okay, whatever. But what if I had another test, like a second test function? I'd have to construct those page objects again there, right? They use the same search page and all. What if I had another test? Copy and paste that code again. Ooh, we're duplicating code. Who likes to duplicate code? Nobody likes to duplicate it. Don't repeat yourself. Well, it'd be really nice if we could make some sort of setup thing that is shared for creating these page objects and injecting them into our tests. I wonder if there's a way we can do that in pytest. That's what fixtures are for. As a recommended practice, I recommend creating fixtures to create your page objects and then declaring them to inject them into your pages. So fixtures are a bit of an advanced pytest thing. A lot of times you may use fixtures and not even know it. And so building your own fixtures may seem something new or may seem intimidating, but it's actually pretty straightforward. Nothing to be afraid of. In fact, we've already used a fixture for the page from Playwright here. So to make fixtures, we're going to go to our tests directory, and we're going to create a new file. It's going to be called conftest.py, C-O-N-F-T-E-S-T. Conftest.py, the name matters. You can't make this arbitrary. It has to be conftest.py. This is a special pytest module that you add to your test directory in order to share things, such as fixtures. So let's add the fixtures to conftest.py. I'm going to need to import all of the stuff that I had in my test case, except the expect function. Oh, geez, no. Don't do that. Okay, so, no, what? Why didn't you copy? Come on, Control-C. Don't do that to me. There we go. And I need to import one other thing. I need to import the pytest module directly. Then I can make my fixtures. And fixtures are just functions that build things. So I'm going to make a function, define, let's do the result page, because it's alphabetically first. Result page. And again, so in order to build a result page, we need the Playwright page. And this is going to return a Duckduckgo result page. And so to construct this is return Duckduckgo result page, page. Boom. Okay. That's all there is to a fixture. We only need one more thing. We need to add a decorator to this function to identify it as a pytest fixture. Decorators are these things that you tack on the top of functions and maybe sometimes classes. They begin with an @ sign, and in this case, and then the name of the decorator. In this case, it's pytest from the pytest module, .fixture. And now what will happen is, anytime you run a test and your function has an argument named result page, pytest will look in all the fixtures it knows to see if it has a matching name. If it has a matching name, it's going to call that fixture. And then when it calls the fixture and it's done, it's going to inject whatever's returned into your test case as an input. It's really cool dependency injection. This is one of my favorite things about pytest. So we have a fixture for our result page. We're also going to do a fixture for our search page, and that's going to be the Duckduckgo Search page, and a Duckduckgo Search page here, and now what happened? Oh. Seach. Wow, I'm going to seach it. Great. Thankfully, I had a good editor as well as some very awesome code reviewers to help point that out to me before it became a problem. Oh my gosh, I love it. Teamwork makes the dream work. Okay, so now I have my two fixtures, and what I can do is I can come back to the test search class, and instead of having to instantiate those objects every time, I can declare them as fixtures for my test case. So I can say I want to search page, and that's going to be the Duckduckgo search page. And I can declare the result page fixture Duckduckgo result page. I don't need to directly import the fixtures. PyTest has magic that it will just automatically discover it and call it. But yeah, and so now I've removed that extra thing from my test procedure. And so my test very much is really just focusing on the interactions and the verifications. And if, as you guessed it, if we run it, it should work. Boom! 4.868 seconds. That's awesome. Woo! Cool. Awesome. So any questions about that? Pretty straightforward? Everybody got it working? Yeah, nodding heads. I know, home stretch, 28 minutes left. We got this. We got this. So at this point, we are pretty much finished writing the test case. Good job, everybody. We did it. We made it. Not only did we automate our first test case in Playwright, but we did it well with page objects. Sweet. Okay, so where do we go from here? What I'd like to do for the rest of the time is I'd like to show you some of Playwright's more advanced tricks. Primarily around how you can run cross-browser testing, run in parallel. What other things do I have up my sleeve? Oh, parameterization maybe if we get there. Oh, and screenshots and stuff. All right, here we go. I'll also caveat, there's more to Playwright than I can show here today. The Playwright team is very active. Every month or two, they're popping out a new release that has some awesome features. So today, I am not going to demo things like the trace logging. I'm not going to demo the network scraping and stuff. But there's a lot of stuff out there that is really awesome to learn, and the docs are very well kept up to date. So I just want to show you some of the smaller, simpler things that are quick value that most people will get really good value out of. So with that, let's scroll up the terminal here. Clear. As I mentioned before, Playwright uses 3 browser projects. What were they? Chromium, Firefox, WebKit. And that covers pretty much all modern web browsers, right? Chromium is the base project for Google Chrome, Microsoft Edge, and Opera. So, Firefox, clearly for Mozilla Firefox, and WebKit for Apple Safari. So with that, you're hitting the vast majority. IE, that's old, right? That's deprecated. We don't care about that anymore. We're not going to bother with it. And Playwright is just like, screw IE. We're not going to add coverage, right? Because we all know IE is the one that's in the corner over there. It's always giving problems. If you need to test IE, sorry, can't use Playwright. Unless you do, there's a way you can do it indirectly with Apple tools, which is really cool. But most intents and purposes, IE, no. And that's okay. One talk. Back about 2 months ago, I gave a talk at a conference about cross-browser testing. And I was trying to be funny. I was trying to make jokes. And so it was pre-recorded video. So in the video, I was naming off the different browsers. I was like, you can test in Google Chrome, and the Chrome icon goes up. You can test in Firefox, and the Firefox icon. Apple Safari, and the compass goes up. Or you could do IE, and I used the poop emoji. Everybody died laughing. It was beautiful. So anyone who had to use IE, you understand. If not, count your blessings one by one, because IE, oh my gosh, it was pain. There is pain. It didn't used to be that way. It used to be IE was 20 years ago the good thing, and then it turned into the bad thing. Anyway, hot takes, opinions, take them for what you will. So we have 3 browsers we can test against. If we don't specify which browser to test against, by default, the plugin will use Chromium. But we could use the -- browser command line option, and let's say do Firefox. And it'll run it in Firefox. Boom, look at that. That wasn't Chromium, that was Firefox. Oh, and it's going to do the thing again. Sorry, what? Where I don't see. Oh, that's interesting. Oh, because it would be the nightly Firefox build that it sucked down and used. Because it's not a browser, it's a browser project, therefore it's like an open source repo that it's... Oh, and it did that thing again. Okay. Well, it did test it in Firefox. Sorry about the error. If I wanted to do WebKit, you guessed it, I could do this. Browser WebKit, boom, boom. Please don't blow up on me. Oh, it's doing the thing again. Yeah. But you can see this is clearly WebKit and not Chromium. Just X out of this and call it Dunzo. Also, another cool thing is you can do multiple browsers at the same time. So if I wanted to do all three at the same time, browser, Chromium, browser, Firefox. I can do all three at the same time. And now, if you saw, it was doing 3 at once. Collected 3 items. And it'll be doing them sequentially. So unfortunately, because it's doing that, oh my gosh. That one's going to fail. But it brings up the next one in sequence, and this is Chromium. And now Chromium's going to do that thing too. And then, yeah, pretend it's working. I'm so sorry. And yeah, that's stuck too. Yep. But you can see it spills out, you know, the 3 different kinds of tests it did. I wonder if doing it headless might be any better. Let me try that just out of curiosity. Doesn't look like it. Oh, yep, it did. Okay, cool. So that's passing now. Headless is magic. Yeah, okay. So here we can see I ran all 3 browsers at the same time. It ran them sequentially, and it only took 11 seconds. That's actually really good. Typical industry expectations. Unit tests, how fast do you think they typically run? Like a single unit test. Like really fast, like split second. Let's say like order of magnitude a millisecond. How about like an API test where you have to make a REST API call and get a response back? About a second, right? 1 second, order of magnitude. Web UI test usually takes about a minute. Now, the smaller the app and whatever, the faster it is, maybe a little faster, but order of magnitude compared to the others, like you're testing some applications. Typical web test, especially with Selenium, can be like a minute long, if not more. That's what we call the rule of ones for thinking in terms of magnitude. That's why we like to have more unit tests and fewer end-to-end tests. But with Playwright here, this was pretty fast. 3 tests, 11 seconds. If we wanted to speed this up even more, we can go parallel. So for all y'all who have done testing, has anyone tried doing parallel testing? Anyone? No, everyone's tried to run serial. Oh my goodness, okay. Run your tests in parallel. Please run your tests in parallel. Save yourself some time. When you have a well-structured architecture for your test project, it should be very simple to simply flip a switch and make it parallel and have it all safe. The only thing you should have to consider, if you've done good coding, then is making sure shared data in your application is safe and protected too. Because we're using Playwright with pytest, every one of our tests would be independent, kind of on its own little, own isolated little bubble. Therefore, I should be able to flip a switch here, make it parallel, and these tests should run no problem, right? Because they're also, when they're searching Duckduckgo, they're not affecting each other. If you want to run in parallel, it's not a Playwright thing, it's going to be a pytest thing, right? Playwright has the concern of browser automation. pytest is the test framework. We do need another package, so we need to do a pip3 install pytest-xdist, X distribution. So let's install that. Boom, boom. Now what I can do for my command line, I will use the same command, still headless, 3 browsers, but now I'm going to say -n and give it 3. This means 3 parallel threads, or 3 concurrency level max 3. And if I run this, now it's going to run them all in parallel and hope that it doesn't do the other thing. Oh, it looks like 2 of the browsers are hitting A/B testing. If it all works, they usually go like pew, pew, pew. Let me try that again. see. True, true. Come on, give me magic, please. It's doing it again. Because it should go like pew, 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 and you'd see it like 3 tests in 5 seconds instead of 11. That's amazing. But it looks like it's not going to do that. All right, I'll try headed and see what happens. And boom, boom, boom. 1 pass. Who's hanging? Yeah, it's going to be annoying. Okay, well, just trust me on that. Maybe you're getting different results on your machine. I'm going to have to redo this project for the next time.
So their tests are conflicting with your tests.
Oh my gosh. Jeez. Can't win, of course. Oh well. But you get what I'm saying. You can easily parallelize and do that cool thing. So another cool thing you can do with Playwright from the command line is you can capture artifacts of data from your test run. So think about this. Like when a test passes, everything's good. And you're like, okay, move on to the next one. But when a test fails, you know that you as tester, developer, whoever is going to have to go in there and figure out why it failed, right? And if all you have is like a little red X, that's not very helpful, is it? What do you want? You want to be able to see the page in the moment that it failed. So if you can get a screenshot and look at it and be like, that's what went wrong, makes your root cause analysis a lot simpler. Playwright has the capability to automatically capture screenshots after tests. You can also explicitly capture a screenshot at any time, but from the command line to be able to say, like, upon test failure, capture it and save it for me, so much easier. So to do that, I'm going to not run parallel here. We'll go back to just running on Chromium. Tests. To do that, I can say screenshot as a command line option. And I can say on if I want to capture a screenshot after every single test, pass or fail. Or I can say, hold on, where is it? Only -on failure. And so it will only capture a screenshot in the case it fails. Because, yeah, if a test is passing, do you really want the screenshot? I don't know. So anyway, we'll turn it on so we can just show how that happens. So it runs, boom, passed, oh thank goodness. And here, it creates a folder called test results. I have my screenshot. Well, that's a little tiny. But here you can see that was where the test was, or that's where the page was at the end of the test. And also I should note that even though I ran it headlessly, it was still able to capture that screenshot. Question?
Can you export a GIF of the whole test instead of just a static?
Ooh, can I export a GIF? You mean like a video?
Yeah.
Video would be so much more helpful, wouldn't it? Because you see the whole progression. Can I do video? Yes, you can. Oh, yes. It's amazing. So, same thing. Instead of screenshot -- video, and again, you can have it for on for everything, or it's retain on failure if you only want to save the failed ones. So we'll do it on just in case. And so now when we run it, let's see what happens. Please, please, please don't take 30 seconds. It's going to take 30 seconds. Well, that's okay. We'll wait for the 30 seconds and see the video and watch it play for 30 seconds. But yeah, it captures it in I think the format file is like Web3 or something, or WebM. It's not MP4, which I thought was weird, but I think they do it for open source reasons and compression reasons. But yeah, you can automatically capture video. Yes?
I noticed when you started this test, your other directory with the screenshot went away. Does that happen every time you run the screen?
Yes, that is something you need to be careful of. Yes, yes, yep. So here, test results. Here's this thing I'm going to open or reveal in Finder. It's going to open in Edge. Oh, gosh, Chrome. We can open Chromium. It'll do it, right? Yeah. So here's the video. Boom, boom. And then Oh, that just wasn't loading. Oh, that was probably because it was blocking me, not because of the A-B thing. We're losing twice over today. But anyway, this is actually a good teachable moment to show when your test fails for a bug, you can easily see, much more easily than a screenshot, you can see the whole flow in a video. And that's why video is very valuable. Selenium does not do video, period. Like you have to hack something. Like you can do it, but it's a real nasty hack. Playwright, it's a command line option. Question? Yes, yes. So like I showed before from the command line, -- browser, you choose the browser you want to run.
Oh, I mean, like, can you just say pytest, and then it'll figure out which browsers to run tests on based on parameterization?
You mean pytest parameterization?
Yeah.
So you want to hard code browser choice into your test code. That is a horrible anti-pattern. Do not do that. I am not going to show you how to do that. You could jury rig it in. I am not going to show you how. And the reason that's an anti-pattern is because tests should run the same, or I shouldn't say tests. Behaviors should operate the same regardless of the browser. Therefore, tests should work on those behaviors regardless of the browser, so long as they're supported. You may have a nuance of maybe there's like something special going on for whatever. That seems odd to me. I would scream at my product owner for that. But if it really had to go through, what I would do is when I would go launch, I would use pytest tagging and filters to control. I wouldn't embed that in test code. That is a horrible anti-pattern. Don't do that. Don't do that. Please don't do that. Oh, you're hurting. I have heartburn now. Someone has hurt me in my past with that, and now you hurt me again. This is injury. Okay. But still a good question. Alrighty, so we saw the parallelization. I'm not going to show you parameters because we kind of hit that with the cross-browser testing. Yeah, okay. So the last thing I will kind of cover as part of our tutorial today, it won't be a coding thing we do together, but rather a, not that, look at the repo. So I mentioned before, the repository has all the example code from this project. And so there are actually 6 chapters instead of 5. I originally planned this tutorial to be a 5-chapter tutorial, hence it's actually ending roughly on time. And the 6th chapter is what I would consider a bonus chapter. And the 6th chapter covers API testing. One really cool thing about, another really cool thing about Playwright is that you can do API testing as well as web UI testing. It has the ability to make requests and parse responses baked into Playwright. In Python, I'm fairly certain it uses requests under the hood, but it's still nice to have all that context within Playwright. And so what I would encourage you to do as a homework assignment is to complete part 6 on your own. You have the project already in place. You've learned all the good stuff about Playwright you need to do this. I will warn you, though, chapter 6 is a bit more intense. Parts 1 through 5, it was one simple test and basically honing this into excellence, like beating a dead horse on it almost. But this one, the exercise is log into GitHub with your GitHub account, create a project board, and then test creating to-do cards, dragging and dropping, editing, those kinds of things. So a little more real-world, intense interactions. And the test will step you through things like a pure API test, where you simply like create a new card using the API and then fetch it to make sure it's good. Then you do tests where it's API and UI working together, where like you drag and drop one card from the UI, but then you call the API on the back end to make sure that the change synced. Highly recommend that you take this on your own because it'll be kind of like the next level up in your Playwright and your test automation skills. All the instructions are here for you to do. So yeah. Also, the way I designed this tutorial was so that everything is in the repository. So let's say you go back to your office and you say, oh my gosh, team, I went to PyCon and my life changed and it was awesome and now I'm part of the Python community. And I took this really cool tutorial from this weird Panda kid, but he had this awesome project that you can learn this too, so we can make this happen here. Feel free to share this repository. Feel free to encourage people to take it on their own. That can be another way to use this as a resource. You can also use what we built together as the basis of a test automation project that you would want to do on your team or on your own. Just delete the DuckDuckGo test and put your tests and pages in there, and you're good to go. So I hope that y'all have found this helpful. I hope that y'all have found this valuable and enjoyable. Before we close, are there any final questions anyone might have about anything? Playwright, pytest, Python, testing, me, other things. Ask me anything, yes.
I use Playwright and it has auto-generation for code.
Yes.
Would you recommend that? Which cases would you recommend that?
That's a great question. So our friend here in the audience said, I know that Playwright has a code generator tool. Is it good? Is it worth it? Do you recommend it? And if so, how? Playwright's code gen tool is actually pretty good. It's actually pretty decent. What you do is you basically start recording on your browser, you click through, and then it poops out a Playwright script with interactions and selectors. And their selectors are okay. Would I use that for my workflows? Probably not. Why? Simply because I'm old-fashioned and old school. I prefer to have the page on my own, go and inspect the elements, rip them out myself. But I know there are plenty of people whose workflow is, oh, I need to do a test. Let me record it, export that, pop it in my project, and now I'm going to refine it from there. So if you find value in doing it that way, I'd say don't let anyone stop you. Great question. Any other questions? Alrighty then. Well, thank you for your attention. Thank you for your time. Thank you for being here. I really appreciate it. I always love the chance to get to show people cool stuff like this. So again, my name is Pandy Knight. I'm the Automation Panda. You can follow me on Twitter, Automation Panda. Read my blog, automationpanda.com. Ask me things anytime. I'm glad to help. I'll be around PyCon. If you want to learn more about test data, like some of the things I was mentioning before, Sunday afternoon, managing the test data nightmare, I'll be speaking there. And yeah, enjoy PyCon. Oh, and take stickers and postcards. Thank you.